Under a moonlit night sky, a deep silence falls over an ancient landscape. The air is cool and still. Above, countless stars shimmer like distant lanterns hung in a boundless dark. The Milky Way arches overhead, a pale band of light, billions of stars too faint to see individually, blending into a ghostly river across the sky. Here on Earth, far from city lights, you feel the infinity overhead. In the quiet of this night, you are not merely a spectator. You are part of this vast cosmos. Every atom in your body was born in the heart of a star long ago. As you gaze upward, you might sense a gentle connection, a realization that the starlight touching your eyes has traveled for years, perhaps centuries, through space to reach you. In this moment, the line between out there and in here blurs. The universe is not separate from you. It's within you, around you, and you within it. The night sky was also humanity's first compass and calendar. Long before GPS or clocks, people looked to the stars to guide them. Travelers learned to follow the steady North Star or used the rising and setting of constellations to find their way. On the open ocean, Polynesian navigators memorized the positions of hundreds of stars and their seasonal movements, steering canoes across vast distances, using only the heavens. By observing the stars and their yearly patterns, our ancestors marked the seasons, knowing when to plant or harvest. The sky was a map and a timetable written in light. We trace patterns among the stars, the constellations, weaving stories and myths. For example, look at the constellation Orion, visible on a clear winter night with its 3-star belt. The ancient Greeks imagined Orion as a mighty hunter in the heavens. In one legend, he chases across the sky, and each year when the Scorpion constellation Scorpius rises, Orion sets, as if eternally fleeing the creature that in myth brought about his demise. Yet far across the world in the South Pacific, some Polynesian peoples gazed at those same stars and saw not a hunter, but the outline of a great canoe sailing the celestial ocean. What one culture perceived as a hero with a bow, another saw as a vessel guiding seafarers by the stars. Consider also the little cluster of stars called the Pleiades. On a dark night, you might count 6 or 7 of these tiny bluish stars clumped together. Nearly every culture noticed this delicate cluster and wove stories around it. To the Greeks, they were the 7 sisters, pursued by Orion or placed in the sky to commemorate sisters turned to stars. In Maori tradition in New Zealand, this cluster is called Matariki. Its annual rising at dawn in winter marks the new year, a time of remembrance and planting for the spring. To the Kiowa people of North America, the Pleiades were once 7 little girls who escaped a bear by rising to the sky, while the bear's claws etched the grooves of Devil's Tower in their legend. Different peoples, widely separated, all felt these stars were special and gave them meaning through story. Even the Milky Way, that broad band of light, has its tales. Some called it the River of Heaven, a pathway for souls or gods. In a Chinese story, it is a silvery river that separates 2 lovers, the star Altair, a herdsman, and Vega, a weaver girl. They are allowed to meet just once a year, when a bridge of magpies forms across the sky. On that night, people look up and celebrate their reunion. In other places, the Milky Way's dark patches form shapes too. For instance, some Aboriginal Australians see in the darkness, between the stars, the silhouette of a great emu stretching across the sky, where one person sees stars, another sees the spaces between them and finds a picture there. These varied stories show a universal truth. Across continents and centuries, human beings looked upward and felt the need to connect those distant lights into familiar patterns, to bring the sky into our world of meaning. The constellations became a canvas for our imagination, a mirror reflecting our own experiences, hopes, and fears. And though the characters and symbols differ, the act of storytelling under the same stars links us all. Imagine, lying here in the grass, that someone on a planet circling one of those distant stars is also looking up at their night sky. Perhaps their sky has 2 moons, or rings like Saturn, or clouds of colours we've never seen. They too may wonder if they are alone. In our own way, as we peer at the stars, we wonder about them. In this shared curiosity, the cosmos feels a little more intimate, as if all who gaze up at the stars are linked by a common thread of wonder. For now, the universe keeps its secrets. If we are alone, then these quiet nights carry an even greater weight. We are the eyes of the cosmos, the means by which the universe beholds itself. If we are not alone, then someday, perhaps far in the future, our descendants might meet other beings under some alien sky, and the universe will have new voices to know itself. Either thought fills the heart with a gentle awe. In the meantime, we do not simply wait in silence. Over the years, we have sent our own messages into space. We have built mechanical envoys that journey beyond the planets, each carrying a small piece of humanity, a golden record of our sounds and greetings, a plaque etched with our place in the cosmos. We have beamed radio hellos into the dark, hoping someone might listen. With each probe we launch and each ear we turn skyward, we affirm a quiet hope that we are not alone in this vastness. And even if no reply ever comes, the very act of reaching out is its own kind of comfort, a reminder that we share the same stars and the same wonder. As you inhale under the night sky, the air filling your lungs carries atoms, exhaled by trees and ancient forests, atoms that have drifted through clouds and across oceans to reach you. Those atoms have been part of countless forms of life before finding their way to you. As you breathe in, you take in air that has drifted beneath the same stars for eons, air carrying atoms exhaled by trees and ancient forests long ago, atoms that have been part of countless forms of life before finding their way to you. Exhaling, you become one with the night. The soft chorus of crickets or the distant rustle of leaves is the soundtrack of Earth's night, a reminder that even in darkness, life endures here. Your heartbeat is steady, calm, almost echoing the rhythms of the world turning under the sky. Relax and feel the earth beneath you and the cosmos above, cradling you between them. In this moment, allow yourself to simply be. Feel the cool ground supporting you and the vast sky above, inviting your thoughts to wander. With each slow breath, let any tension ease. As you inhale, draw in the peace of the night. As you exhale, release your worries into the darkness. You are safe here, a tiny part of this great universe, connected to it and cradled by it. High above, one light is larger and brighter than the rest tonight. The moon. It hangs low on the horizon, a silver disk beaming gently down. Moonlight paints the ground in a faint glow, casting soft shadows of trees and hills. Our moon, Earth's faithful companion, has watched over the night for billions of years. How many generations have looked up in wonder at that glowing face, seeing stories in its patterns of light and dark. Some see the face of a man, others a rabbit or a woman. All across the world, people have given the moon names and legends, a testament to its hold on our imagination. Throughout cultures, the moon became a symbol of comfort and connection. Two friends or lovers separated by distance could look up at the same moon and feel a little less apart. Its gentle glow has inspired poems, songs, and hopeful gazes. Even when the world is dark, the moon softly assures us that we share the night together under its light. The moon is a world unto itself. Its surface is covered in craters from ancient asteroid impacts and dark plains of solidified lava called Moria, once thought to be seas. Astronomers believe the moon itself was born in cosmic violence, that billions of years ago, a Mars-sized protoplanet collided with the young Earth, and the debris from that cataclysm coalesced into our moon. In its infancy, the moon was a glowing ball of molten rock. Over time, it cooled and solidified. Meteoroids and asteroids pelted its surface for eons, scarring it with craters and creating the grey, pitted landscape we see today. Yet those dark plains, the Moria, are remnants of ancient lava floods that filled huge basins long ago, giving the face of the moon its familiar patches and shapes. If you could stand there, you would see a grey, dusty landscape stretching under a black sky, where the sun blazes without an atmosphere to soften its light, and the Earth would hang above the horizon, a beautiful blue and white sphere. Because the moon rotates just once each time it orbits Earth, one hemisphere always faces toward us. That means if you were standing on the near side, the Earth would hang in the sky and hardly move, always showing the same face. Conversely, the moon's far side remained completely hidden from human eyes until spacecraft orbited it. We discovered a terrain even more heavily cratered, without the large seas visible on the side that faces us. Even our familiar moon kept secrets until we had the means to unveil them. There is no air to carry sound, no water flows. An eerie stillness pervades. And yet it's not completely dead. The moon's presence has a profound effect on Earth. Its gentle gravitational pull tugs at our oceans, drawing tides in and out, as if breathing on behalf of the sea. It also serves as a stabilizer for our planet. The moon's steady pull helps keep Earth's axis tilt from wobbling wildly over long ages, ensuring a relatively stable climate and the regular cycle of seasons that have nurtured life on Earth. For all of history, the moon has been our companion and guide. Its phases, from slender crescent to full brilliance and back, mark the passage of time. Early calendars were set by its cycle. By its light, ancient travellers could find their way at night. Many a night, our ancestors must have sat by a fire, weaving tales that took place under this same moon, or gazing at it and pondering what it was. It was once a mystery, a goddess or a god in the sky, or a lantern hung by the divine. And once in a great while, the moon offered spectacular shows. Sometimes it slid into Earth's shadow, glowing a dim red in a lunar eclipse. Other times it drifted exactly between Earth and Sun, turning day to eerie twilight in a solar eclipse. Such events must have astonished and mystified ancient observers, perhaps seen as dragons swallowing the moon or sun, or as omens from the gods. Even now, knowing the science, many find that watching an eclipse stirs a primal awe within. In July of 1969, human footprints were pressed into the lunar soil, turning what was once myth into reality. For the first time, we truly touched our celestial neighbour. Imagine the silence the astronauts felt standing on that alien ground, Earth shining above them in the blackness of space. Those footprints remain, undisturbed by wind or rain, perhaps for millions of years. When we look at the moon now, we can whisper a quiet greeting, knowing that a part of us has been there. Standing here on Earth, bathed in moonlight, we feel the moon's quiet presence. Its cycles have subtly guided life's rhythms for ages. Some say it influences the sprouting of plants or the spawning of fish, even the moods of humans. Whether or not the legends hold truth, there is undeniably a connection. The moon, circling us each month, reminds us that we are part of a greater dance. As night passes, eventually the eastern sky grows lighter. A few stars still linger as the darkness thins. The moon, if it's still up, pales and fades into the brightening blue. Dawn is arriving, and then, gracefully, the sun peeks over the horizon. The world is painted gold. Dewdrops on grass glint like tiny stars brought to earth. The chill of night gives way to a gentle warmth on your skin. It's morning, and our journey now turns to the star that makes it all possible. The sun that now warms your face is no ordinary star to us. It is the heart of our solar system, the giver of light and life to our world. We are creatures of this star. Its rising makes the world come alive each morning, and its setting brings rest at night. Birds sing at dawn to greet it. Flowers turn toward its light. Even our own bodies respond to its daily arrival and departure, waking with its warmth and growing sleepy under the dark when it leaves. The sun's gravity also holds our family of planets together, keeping Earth and its neighbours in their steady orbits. In the sky, it seems modest, a perfect circle of warmth, but this is only because of our great distance. In truth, the sun is a roiling sphere of plasma over 100 times wider than Earth. Inside its core, unimaginable pressure fuses atoms together, releasing the energy that will become sunlight. It takes tens of thousands of years for that energy to work its way from the core to the surface, and then just 8 minutes to stream across space to Earth. Every beam of sunlight you feel on your skin is a traveler from the sun, bringing the gift of warmth and energy. And the sunlight is the source of life's nourishment. Green plants capture its energy through leaves, growing food that sustains animals and us. In a sense, nearly every meal we eat is stored sunshine. Our sun is just one among countless stars, an ordinary yellow dwarf in a galaxy of billions. Yet for us, it is uniquely important. It is our star, the one that makes home possible. For countless cultures, the sun was revered as a deity or a divine gift. And indeed, without the sun, Earth would be a frozen, lifeless rock drifting in darkness. We orbit at just the right distance, the Goldilocks zone, where warmth can nurture life but not scorch it away. And as our Earth orbits yearly around the sun, the tilt of Earth's axis causes the sun's path in the sky to change with the seasons. In summer, the sun climbs higher and days are long and warm. In winter, it stays low and days are short and cool. Since ancient times, people have marked the sun's steady cycle, building monuments to catch the sunlight on the solstices celebrating the return of longer days after the winter solstice, or giving thanks for abundance at harvest when day and night equalize at the equinox. The very calendar of the year is tied to Earth's journey around our star. Each day, the sun rises and greets us, and each night it departs, reliably, like the beating of a cosmic heart, keeping time for all living things. Each sunrise washes the sky in hues of rose and gold, gently waking the world, and each sunset bids the day farewell in a blaze of orange and purple, easing us into night. Sometimes, after a storm, the sun's rays paint a rainbow on the departing clouds, a fleeting bridge of colours that reminds us of the light's gentle magic. If you close your eyes under the morning sun, you can feel its gentle heat on your eyelids, painting a reddish glow in your sight. Birds begin to sing, flowers open. The sun's presence shapes every waking moment of life's cycle. Yet this familiar warmth is actually the mild touch of a tremendous power, raging 93 million miles away. On the sun's surface, magnetic storms flare and leap, sometimes ejecting great waves of charged particles into space. When these solar winds reach Earth, our planet's magnetic field channels them towards the poles, where they ignite auroras, shimmering curtains of green and purple light that dance in polar skies. It's as if the Earth itself has its own gentle nightlights, powered by the sun's breath. Despite its constancy in our lives, the sun is ever-changing. Sunspots, cooler, darker patches, come and go on its face in cycles. Every 11 years or so, the sun's magnetic activity peaks, and the surface seethes with spots and flares. And over millennia, even the sun ages. Billions of years from now, it will swell into a red giant star, engulfing Mercury and Venus, and making Earth uninhabitable. The sun is about halfway through its life. It has shone for over 4.5 billion years, and will shine for billions more before it changes dramatically. But for now, and many eons to come, it will continue to shine steadily, a reassuring presence in the sky. Let us imagine for a moment we can leave Earth behind and journey closer to the sun. As we draw nearer, the sunlight grows fiercer, the glare overwhelming. We would encounter two small worlds circling close to the sun, Mercury and Venus, the inner planets. They are our nearest planetary neighbours on the inward side toward the sun, and yet they could not be more different from our earthly home. First, Mercury, a scorched little globe, the closest planet to the sun. Mercury stays near the sun in the sky, so we can only glimpse it during brief twilights, low on the horizon, in the glow of sunrise or sunset. In the twilight of dawn or dusk, Mercury sometimes appears as a tiny elusive point of light near the horizon, but it never strays far from the sun's glow as seen from Earth. Mercury was named for the fleet-footed messenger of the Roman gods, perhaps because it moves so swiftly across the sky. It races around the sun in just 88 Earth days. Up close, Mercury is stark and barren. It looks a bit like our moon, grey, cratered and airless. Daytime on Mercury is brutally hot. The sun's glare is up to 11 times stronger than on Earth, and the surface temperature under the noon sun can soar to levels that would melt lead. But Mercury has virtually no atmosphere to hold that heat, so at night all the warmth radiates away into space, and the land plunges into deep freeze, colder than the coldest places on Earth. And those days and nights on Mercury are astonishingly long. Because Mercury spins so slowly on its axis, a single day-night cycle lasts about 176 Earth days. The little planet lingers under the sun's glare for weeks at a time, and then endures an equally long, frigid night. Yet even on this sun-scorched world, there are pockets of eternal shadow. In some deep craters near Mercury's poles, the sun's rays never reach the ground, and in those dark vaults, temperatures stay low enough that water ice persists, frozen for eons. It's a startling thought. Ice on the closest planet to the sun, hidden away like a secret. Imagine standing on Mercury's surface. The sky is black even at noon, because there is no air to scatter the sunlight into a blue haze. The sun looms 3 times larger than we see from Earth, blazing fiercely. The ground around you is ancient, covered in fine dust and rock. There are craters hundreds of miles across, reminders of an early era when impacts were common. In one hemisphere, a colossal crater basin named Caloris, formed by an ancient impact, spans more than 1,000 kilometers, its concentric rings still visible. On the opposite side of the planet, the force of that long-ago collision shook the ground so hard it created hilly terrain, as if the planet itself rang like a bell. Mercury is a world of extremes, searing days, frigid nights, and silence. No wind ever blows across its surface, no rain ever falls. It is locked in a perpetual stillness, enduring the sun's glare. Travelling outward from Mercury, we come next to radiant Venus, the second planet from the sun. To the eye, Venus is the brightest planet in our skies, often appearing as the morning star before dawn or the evening star after sunset, outshining all other points of light. It has an inviting name, given for the Roman goddess of love and beauty, and from afar, Venus's shrouded white clouds make it look like a gleaming pearl suspended in space. Yet beneath that beautiful veil, the reality is astonishingly harsh. Venus is often called Earth's twin, because it is nearly the same size and mass as Earth. But it is a twin in appearance only, not in character. Uniquely, Venus spins backward compared to most planets, so on Venus the sun would appear to rise in the west and set in the east, though the perpetual clouds would hide it. A day on Venus, one full rotation, takes longer than a Venusian year orbiting the sun. Imagine descending through Venus's cloud layers. At first you might pass through banks of sulfuric acid clouds that eternally cloak the planet, reflecting sunlight back and making Venus so bright to our sight. The sunlight gets dimmer as you go deeper, tinted in orange hues. The air grows hot and thick. By the time you reach the surface, it's like arriving at the bottom of a vast, hot ocean. Except the ocean is the air itself. The pressure is crushing, over 90 times the pressure at Earth's sea level, as if you were nearly a kilometre beneath the sea. The temperature is a searing 460 degrees, hot enough to melt lead, and it remains that hot everywhere, day or night, because the dense atmosphere holds heat in a runaway greenhouse effect. The landscape, as revealed by radar and a few hardy probes that survived only brief moments on the surface, is rocky and desolate, strewn with boulders and gently rolling plains of volcanic rock. Volcanic mountains and vast lava flats tell of a world reshaped by ancient eruptions. If you could stand on Venus, you would see a dim orange glow everywhere. The sun is just a lighter patch in the perpetually overcast sky. There are no stars to be seen, no break in the clouds, just a hazy, hellish twilight at all times. Wind on the surface moves sluggishly, but with the density of the air, even a slow breeze would push like a strong gust. Sometimes lightning flickers in those clouds, illuminating the gloom for a brief moment. Above the clouds, fierce winds race around the planet at high altitudes, circling Venus in just a few days, even though the surface below turns ever so slowly. It is an incredibly hostile environment, yet it fascinates us. Venus is a warning in some ways, a vision of a world almost the same size as ours, that took a very different path. Long ago, Venus might have had oceans and mild temperatures, but something went awry. The planet's water evaporated, carbon dioxide built up in the atmosphere, and a runaway heating occurred. Now it is a furnace. Still, when we look up at its bright glow in our sky, it's hard to imagine such conditions below those clouds. For millennia, people saw Venus as a lovely star-like beacon, never guessing the truth. Only in the last century, with science and spacecraft, have we peeled back the curtain of cloud. We drift farther outward now, leaving the brilliant skies near the sun. Passing by Earth's orbit, we take a moment to appreciate our own planet from a new perspective. Now, at last, we come to the third planet from the sun, our home, Earth. Seen from space, Earth is breathtaking. A blue marble swirling with white clouds, brown and green landmasses, and deep blue oceans. It hangs against the black void like a jewel. From space, there are no borders or divisions. Just one beautiful planet, fragile and irreplaceable, with a wafer-thin atmosphere embracing it. Many who have seen Earth from above speak of a profound awe, an understanding that we are all part of one world, our fate intertwined on this tiny globe. This is the only place we know of, so far, that hosts life. In all our searching of the skies, Earth remains unique, a sanctuary of water, air, and living diversity, a true oasis in space. On Earth, life flourishes in countless forms. Great whales sing in the blue depths of its oceans. Forests teem with birdsong and rustling creatures. Deserts bloom after rare rains. Even high above, birds and butterflies traverse the skies. From bacteria to blue whales, from rainforest canopies to coral reefs, life has found a way to thrive in nearly every corner. From this vantage point high above, you can see day and night at once on Earth, one half bathed in sunlight, the other in darkness, dotted with the twinkle of city lights. The Terminator, the line between day and night, slowly sweeps across the surface, bringing dusk on one side and dawn on the other, every moment of every day. Over the oceans, white storms swirl. Over continents, green forests and golden deserts give way to the blues of seas. The polar caps gleam white with ice and snow. Thin as a delicate halo, the atmosphere encircles the planet, an almost fragile-looking glow that nonetheless sustains everything we hold dear. Clouds form and dissolve as water cycles from sea to sky to land, a continuous circulation that distributes fresh water and shapes weather. Imagine descending gently through the atmosphere to the surface. You pass through clouds and emerge into the bright sky above a vast ocean. Waves sparkle below in the sunlight. You hear the cry of seabirds carried on the breeze. Everything about this world is inviting compared to Mercury or Venus. The air is the right thickness to breathe. The temperature, in many places, is comfortable. Water flows freely in rivers and rain. Life abounds in every nook, from deep sea vents to mountain tops. Earth is in just the right spot, not too hot, not too cold. Its distance from the sun allows liquid water to persist. Its atmosphere shields the surface from harmful radiation and burns up many incoming meteors that would otherwise strike. A magnetic field generated deep in its core creates a protective bubble around us, deflecting much of the sun's charged particles. All these factors combine to make Earth a cradle for life. Under the warmth of the sun, life flourished. Over deep time, Earth has continually remade itself. Its surface plates drift on molten rock below, carrying continents across the globe inch by inch. They collide to thrust up mountain ranges, then wear down under wind and rain. Oceans open and close, islands emerge and sink. Through these slow cycles of geology, life adapts and endures. Dinosaurs roamed ancient forests and vanished. Ice sheets spread and melted, and still life persisted, evolving into new forms. Our own species is just one of Earth's latest wonders, arriving only a moment ago on this vast timeline, yet capable of gazing back at that history and learning its tales. Blue-green algae in the oceans began producing oxygen billions of years ago, transforming the atmosphere. Plants cover the land, giving us forests and fields. Creatures swim, walk, and fly, each a testament to Earth's nurturing conditions. And among these creatures, one species, us, has developed the ability to reflect on it all, to wonder and to dream about worlds beyond. Our ancestors looked up and recognized that among the stars were 5 special lights that wandered their own paths: Mercury, Venus, Mars, Jupiter, and Saturn, the planets visible to the naked eye. They observed Earth's nearest star-like neighbors without knowing what they were. In time, we learned that Earth too is a planet, one of several siblings orbiting the Sun. That knowledge only increases our appreciation for how fortunate we are. Earth is not at the center of everything, but it is everything to us. In the cosmic ocean, there is no other place yet known where we could live, at least not as comfortably as here. That makes our pale blue dot immeasurably precious. From the vantage of space, one might feel a protective tenderness toward that blue world, tiny, lonely, and precious. If you have ever seen the photograph called Earthrise, taken from the moon, you know the feeling. A fragile blue and white orb rising above the barren lunar horizon. Our entire world floating in the void. And another famous image, the pale blue dot, shows Earth as just a pinprick of light seen from the edge of the solar system. It underscores how precious and singular our world is amid the vast emptiness. A point of light that holds everyone and everything we know. In that little speck, all of human history has unfolded. Every joy and sorrow, every wondering look at the night sky, every exploration and discovery. Take a moment to feel gratitude for this home. Despite the vastness of space and the harshness of other worlds, here we have water to drink, air to breathe, and the gentle light of a stable sun. The story of Earth is the story of us, and as we continue our cosmic journey, we carry a piece of Earth with us in our hearts. Now we venture onward, past our comfortable haven, into the more distant realms of our solar system. Leaving Earth behind, we set our sights on the rusty world of Mars, the fourth planet from the Sun. To the naked eye, Mars is a modest red-orange dot, fainter than dazzling Venus or Jupiter, but distinctly reddish, a celestial ember glowing in the night. Because of its colour, many ancient cultures associated Mars with war or fire. The Romans named it after their god of war, imagining that blood-red hue as an omen. But when we draw near, we find not an angry war god, but a cold, quiet desert planet, beautiful in its austerity. Mars is smaller than Earth, about half Earth's diameter, and it has a very thin atmosphere. As we approach, we see its ruddy surface marked by dark patches and bright rusty plains, and at the poles, caps of white that grow and shrink with the seasons. Once we descend to the dusty ground, the sky of Mars greets us with a butterscotch tint during the day. The sun appears smaller and weaker here, about 2/3 the size it looks from Earth, and the daylight has a golden, sometimes coppery cast because of fine dust suspended in the air. On a clear day, the sky might be yellowish-brown. At sunset, oddly, the sky around the setting sun glows blue as the dust scatters the red light away. Imagine standing on a Martian plain during sunset. The horizon stretches out, a rocky expanse under a dimming pink sky, and to the west the sun sinks, surrounded by a cool blue halo of twilight that fades into the rusty hue overhead. In that quiet moment, you might almost feel like you're in a vast desert on Earth, except the silence is deeper than any desert night, and the air so thin you would need a suit to survive. Mars's landscape tells a story of a more dynamic past. You might walk through valleys that look like dried riverbeds, carved long ago by flowing water. You could climb a mountain that is actually the largest volcano in the solar system, Olympus Mons, towering nearly 3 times the height of Mount Everest, its base so wide that if you stood on its slopes, you would scarcely realize you were on a mountain at all, just a gentle upward plane reaching into the sky. There are gigantic canyons too, valles marineris, a system of chasms that stretches across a distance as great as the width of North America, with cliffs miles high. These features hint that Mars once had active volcanoes, flowing water, maybe even lakes or an ocean in its distant past. Today, Mars is mostly frozen and desert-like. The average temperature is well below freezing. If you touch the ground at midday near the equator, it might be pleasantly cool like a spring day, but by night, it would drop to bitter cold. The thin atmosphere, mostly carbon dioxide, offers little insulation and only a faint pressure, about 1% of Earth's. Occasionally, winds can pick up fine dust and spiral into dust devils that dance across the plains, or even engulf the whole planet in a dust storm that can last weeks, tinting the atmosphere and hiding the surface from view. But in calmer times, the Martian surface lies exposed and still, as it has for eons. Much later, in the late 19th century, Earthbound observers with early telescopes imagined they saw straight lines on Mars, perhaps canals, built by intelligent Martians. This turned out to be an illusion, but it captivated the public and inspired many tales of the Martian inhabitants of our neighbouring world. Such stories fired our curiosity and eventually helped drive real exploration of Mars with spacecraft. Though harsh, Mars captivates our imagination. It's the most Earth-like planet in some ways. It has day and night, seasons, polar ice caps, and a solid ground you could walk on. Over the years, we have sent many robotic explorers to Mars, and they have beamed back images of alien, yet strangely familiar landscapes. orange-hued deserts under pink skies, rocky plains with lonely rovers as the only moving things for miles. We've found minerals that only form in water, and rocks etched by streams, proving that long ago, Mars was warmer and wetter. Because of this, Mars is also a beacon of hope in the search for life beyond Earth. If life ever arose there in the past when water flowed, perhaps signs of it might still be preserved in the rocks. Or maybe in some sheltered niche underground, a few hardy microbes persist even today. We do not know yet, but the possibility fills us with quiet wonder. And in the not-too-distant future, humans themselves may walk on this red frontier, turning distant dreams into reality, just as we did with the moon. Standing on Mars, you would feel lighter. Gravity is only about 1/3 of Earth's. If you looked up during the day, besides the sun, you might see one of Mars's tiny moons, Phobos or Deimos, rushing across the sky. They are not grand and round like our moon, but little potato-shaped rocks, likely captured asteroids, hurtling around Mars quickly. Phobos rises and sets twice each Martian day. Imagine 2 small moons racing overhead, one of them appearing as just a swift-moving star-like dot. In the Martian night, Earth might appear as a bright bluish star if you knew where to look, a reminder of home shining across the void. Now our journey takes us far beyond the inner planets. Past Mars's orbit, we traverse the asteroid belt, a vast collection of rocks and ice chunks that circle the sun like a dispersed cloud. These are remnants of the early solar system, pieces that never formed into a planet, shepherded by the gravity of giant Jupiter beyond. Though often imagined as a dense field of tumbling rocks, in truth the asteroid belt is mostly empty space. The rocks and dwarf planets within are spread out over such a huge volume that our spacecraft usually pass through without incident. Occasionally, 2 asteroids may collide, or a comet may weave through, but mostly they silently orbit, unnoticed. Among them is Ceres, a dwarf planet, round and small, holding quietly onto its own secrets, with perhaps some ice beneath its crust. We drift through this ancient graveyard of planets that never were, onward to the domain of the giants. In the growing darkness, a bright object appears ahead, brighter than any star. We are approaching Jupiter, the 5th planet from the Sun, and by far the largest. Named after the king of the gods, Jupiter truly rules over the other planets with its immense size. Jupiter is a titanic world, a gas giant so large that over 1,000 Earths could fit inside it. Even from a distance, its presence is commanding. As we draw near, the planet's banded clouds come into view, stripes of white, ochre, and red wrapping around a colossal sphere. Jupiter spins faster than any other planet, completing a rotation in just about 10 hours, which stretches its clouds into those long bands. There is no solid ground to land on here. Jupiter is made mostly of hydrogen and helium gas, with perhaps a dense core buried deep inside. Approach too close, and the atmosphere thickens to something akin to a fluid, and deeper still, it might become a strange sea of liquid metallic hydrogen under crushing pressure. But from our vantage point in space, we see only the tops of Jupiter's endless clouds, swirling and flowing in mesmerizing patterns. There are storms larger than Earth itself here. The most famous is the Great Red Spot, a colossal storm that has raged for centuries like a cyclone of crimson and cream. Imagine a hurricane 3 times the size of Earth, perpetually spinning. That is the Great Red Spot. Of late it has been changing, shrinking slowly, but it's still an awe-inspiring sight, a reminder of how dynamic this giant world is. If you were to hover near Jupiter's cloud tops, you'd witness a sky in constant motion, creamy white zones of rising gas, ruddy brown belts of sinking gas, spots and eddies and turbulence where these bands interact. Lightning flashes deep within thunderheads, larger than Everest. Auroras larger than Earth itself dance around Jupiter's poles, glowing electric blue and purple as the planet's powerful magnetic field funnels charged particles, some from the Sun, many from Jupiter's own volcanic moon, into its upper atmosphere. Jupiter's gravity dominates this region, holding a retinue of moons and influencing even the asteroid belt. Indeed, Jupiter acts as a kind of cosmic guardian. Its powerful gravity often captures or deflects wandering comets and asteroids, reducing the number of potential impacts on the inner planets. Over the eons, it may have shielded Earth from many catastrophic collisions, subtly safeguarding life on our small world. Jupiter is like a miniature solar system. It has dozens of moons, more than 80 known, ranging from tiny asteroid-like rocks to enormous spheres rivaling planets. 4 are especially noteworthy: the Galilean moons, first seen by Galileo through his telescope, forever changing our understanding of the cosmos by proving that not everything revolves around Earth. Imagine standing on the frozen surface of Europa, one of Jupiter's moons. The ground beneath you is bright ice, and filling the sky is Jupiter itself, looming huge and striped. It would hang there dozens of times larger than our moon appears from Earth, a banded giant casting a pale light on Europa's ice. It's a sight almost beyond imagination, a sky dominated by a planet. Each moon is a world in its own right, but they all dance around Jupiter, held by its immense gravity, like a miniature model of planets around a sun. Among these moons is Io, a world of fire and brimstone, the most volcanically active place in the solar system, its surface constantly repaved by erupting sulfur and lava. Europa, a smooth, bright ice ball, hides a deep saltwater ocean beneath its cracked icy shell. We wonder if something might swim in its dark seas. Ganymede, larger than Mercury, carries its own magnetic field and a mix of ice and rock, and Callisto, pockmarked with ancient craters, bears scars from the dawn of the solar system. When Galileo pointed his primitive telescope at Jupiter in 1610, he noticed these 4 moons moving around it. This was a revolutionary discovery at the time, clear proof that not everything orbited the Earth, and it forever changed our understanding of the cosmos. Each of these moons is captivating, but Jupiter's embrace holds them all. And like its neighbour Saturn, Jupiter has rings too, though faint and wispy, made of dust from shattered moons, invisible to us until spacecraft spotted them. From Jupiter's distance, the Sun has grown smaller and dimmer, but it still lights up the clouds in soft hues. The sunlight here is about 1/25 as strong as at Earth, but Jupiter's reflective clouds keep it one of the brightest objects in the solar system. As we take one last look at this banded giant, we feel the scale of our journey. We have come so far, yet there are further wonders ahead in the outer dark. Moving beyond Jupiter, further into the cold reaches, we find Saturn, the 6th planet from the Sun, a planet that has captured human imagination, perhaps more than any other, thanks to its magnificent rings. In antiquity, Saturn was the farthest planet known, a slow-moving golden light in the sky. The Romans named it for the god of time and harvest, perhaps nodding to its unhurried journey around the Sun, taking nearly 30 Earth years to complete one orbit. Even from afar, Saturn has a subtle golden hue, its atmosphere calmer looking than Jupiter's, but still adorned with faint bands and whirling storms. Approaching Saturn feels like approaching a work of cosmic art. When telescopes were first turned towards Saturn in the 17th century, Its appearance baffled observers. Galileo thought the planet had strange handles or ears on either side. His telescope was too crude to clearly show the rings. A few decades later, astronomer Christian Huygens realized those ears were in fact a magnificent ring system encircling Saturn. Encircling the planet is an immense, flat expanse of rings, shimmering like a delicate halo. The rings are made up of countless particles of ice and rock, each orbiting Saturn like a tiny moon of its own, millions of them swarming in unison to create broad, glowing bands that span over 100,000 kilometers across, yet are astonishingly thin, in some places just tens of meters thick. Imagine yourself floating just above Saturn's rings. Beneath you, Saturn's cloud tops spread out in hues of butterscotch and cream. Above the planet's pale clouds, you might see slow-moving oval storms, and perhaps a strange, six-sided jet stream around the North Pole, Saturn's mysterious hexagon pattern in the clouds. But the view is dominated by the rings. What appear as solid bands from a distance dissolve into countless glittering shards as you draw near. Chunks of ice ranging from dust grains to boulders race around Saturn in a flat plain. When the sunlight hits them at just the right angle, the rings glow with an almost ethereal light and cast a wide shadow on Saturn's cloud tops below. A dark belt on the planet's face, marking where the rings block the sun. Saturn itself, like Jupiter, is a gas giant, mostly of hydrogen and helium. It's lighter than water. If you could place Saturn in a cosmic ocean large enough, it would float. Its density is low, but its volume is huge. Over 760 Earths could fit inside. The planet rotates quickly, about 10.5 hours per rotation, stretching slightly into an oblate shape, wider at the equator. Through a telescope, this flattening is subtle but real, giving Saturn a slightly squashed appearance. But it is the rings that make Saturn the jewel of the solar system. They are not solid. They are an orchestrated swarm, likely remnants of a moon or a comet that wandered too close and was torn apart by Saturn's gravity eons ago, or debris left from Saturn's formation that never coalesced. Whatever their origin, for now they grace Saturn with a beauty unmatched. And yet, they will not last forever. The rings are slowly changing. A rain of ring particles drifts into Saturn over millions of years, and one distant day the rings may fade or disappear. But in our time, we are lucky to witness them in their full splendor. Saturn is not without its companions either. It has more than 80 moons known to date. The largest, Titan, is a world almost as large as Mercury, wrapped in a thick orange haze of atmosphere. Titan intrigues scientists because beneath its smoggy sky, it has rivers and lakes of liquid methane and ethane, and even rain, a hydrological cycle like Earth's, but with liquid hydrocarbons instead of water. The ground there is water ice as hard as rock, sculpted by methane rains and perhaps volcanoes that erupt not lava, but water mixed with ammonia. If you could stand on Titan's surface, a feat the Huygens probe accomplished in 2005 for a brief time, you might see a dim orange twilight, even at noon, with the sun just a bright spot behind perpetual clouds. On Titan, with its dense atmosphere and low gravity, you could even imagine flying by simply flapping artificial wings strapped to your arms, a dreamlike possibility on that alien moon. Other moons of Saturn enchant as well. Enceladus, a small icy moon, gleams with fresh snow and shoots geysers of water vapor into space from cracks near its south pole, hinting at another ocean beneath the ice. Those geysers feed one of Saturn's rings, adding material to the swarm of particles. Then there's Iapetus, half bright as snow and half dark as coal, with a ridge of mountains running along its equator, making it look like a giant walnut or tiny pan, which orbits within the rings and has gathered ring material around its equator, resembling a little flying saucer. All these moons and the rings create a rich system around Saturn, like a miniature cosmos to explore. But in our gentle journey, we simply take in the view, the serene planet with its shining rings and varied moons hanging in the darkness, illuminated by the distant sun. Out here, far from the noise of Earth, the stillness invites us to pause. Let's take a moment to truly feel this quiet and allow our bodies and minds to relax, as though we too are floating in space. Start by bringing your attention to your feet. Imagine any tightness in your toes releasing. Your feet feel pleasantly heavy and at ease. With your next breath, let that relaxation travel into your ankles and calves. The muscles unclench. The tension drifts away. Now feel your knees and thighs soften. Your legs become comfortably weightless, as if buoyed by the gentle void around us. Take another slow breath, and on the exhale, let go of any stiffness in your hips and lower back. Feel your belly and chest relax. Your breathing remains easy and calm, like a slow tide. As you inhale, picture the air nourishing you. And as you exhale, feel any stress melting downwards, pulled away harmlessly by gravity. Your heartbeat is steady, unhurried, in tune with the deep rhythm of space. Let the relaxation spread to your shoulders now. They drop away from your ears, loose and free. Your arms grow warm and limp, your hands resting softly. Every finger uncurls, releasing any remaining fatigue. Finally, turn your attention to your neck and head. Let your neck muscles loosen, your jaw unclench, your face smooths, eyes soft under your lids. Your whole body is now enveloped in a calm comfort, floating as though in a safe cosmic cradle. In this tranquility, you can sense your connection to the universe around you. The same force that guides the planets in their orbits gently holds you here, at peace. Now, gently let your attention return to our voyage. Beyond Saturn's orbit, the solar system holds two more great planets in its farthest realm. Let us continue outward into the cold twilight where Uranus and Neptune await. Beyond Saturn, the sun grows ever more distant and dim. Yet our journey continues to the two outermost planets, Uranus and Neptune, the ice giants drifting in the far twilight of the solar system. First we come to Uranus, a pale blue-green world rolling around the sun on its side. Unlike any other planet, Uranus is tilted over so far that it essentially rolls through its orbit, likely due to an ancient colossal impact. This unique tilt gives it extreme seasons. Each pole spends over 20 years in continuous sunlight, then 20 years in darkness. Uranus appears as a smooth, featureless sphere at first glance, its clouds mostly hidden beneath an atmosphere rich in hydrogen, helium, and a trace of methane that lends the planet its gentle aqua hue. Methane absorbs red light and reflects blue, painting Uranus in pastel tones. The sun here is just a tiny, bright disk, providing a faint illumination. A midday on Uranus would feel like deep dusk on Earth. As we draw closer, we see that Uranus too is encircled by rings, narrow, dark bands of dust and rock that loop around its equator. They are much thinner and dimmer than Saturn's majestic rings, but they are there, whispering of the planet's subtle beauty. Dozens of moons also accompany Uranus. Most are small and icy, but a few stand out. One moon, Miranda, looks almost pieced together from mismatched fragments. Its surface, a crazy quilt of cliffs, grooves, and craters as tall as Mount Everest, perhaps shattered and reassembled by past impacts. Another, Titania, carries canyons and fault lines hinting at geological activity eons ago. If you could float above Uranus's atmosphere, you might find the environment strangely tranquil. The planet's weather is subdued, with only faint bands and occasional storms visible. There is an eerie calm to this distant ice giant, as it silently traces its lonely path around the Sun over 84 Earth years. Moving further out, we arrive at Neptune, the eighth and farthest known planet from the Sun. Neptune is a rich cobalt blue, deeper in colour than Uranus. Its vibrant hue comes from a similar methane presence in its atmosphere. But Neptune is more dynamic and stormy. Here, more than 4.5 billion kilometres from the Sun, daylight is only a ghost of what it is on Earth. Yet Neptune possesses internal energy that fuels wild weather. Winds here are the fastest in the solar system, whipping clouds of methane ice into constant storms. Voyager 2, the only spacecraft to visit Neptune, spotted a dark oval storm near Neptune's equator, dubbed the Great Dark Spot, a tempest as large as the Earth, which vanished a few years later, only to have others appear elsewhere. White clouds of methane ice, nicknamed scooters, zip around the planet at high speeds. In Neptune's upper atmosphere, supersonic winds create a perpetual tumult, even as the sun's rays are feeble. Neptune, too, is encircled by thin rings and accompanied by moons, 14 that we know of. The largest, Triton, is a world almost as intriguing as Neptune itself. Triton orbits Neptune in the opposite direction of Neptune's rotation, a retrograde orbit, suggesting it was likely a captured object from the Kuiper belt, now ensnared by Neptune's gravity. Triton's surface is a frozen landscape of nitrogen ice, with geysers that erupt sublimated nitrogen gas in the faint sunlight, creating dark plumes that drift in its tenuous atmosphere. If you stood on Triton, you'd see Neptune as a great blue disk in the sky, softly illuminating the icy plains. This distant moon is gradually spiraling inward. One day, far in the future, Triton may break apart into rings, giving Neptune a more spectacular adornment. For now, it remains an enigmatic, frigid companion circling a planet where the sun is merely a bright star in a perpetually twilight sky. Out at Uranus and Neptune, the boundary between day and night blurs into an eternal dimness. The stars begin to dominate the sky as the sun shrinks in the distance. The cold is intense, hundreds of degrees below freezing. Everything is hushed. We are nearly at the edge of the planetary realm, where the solar system starts to give way to the deep beyond. And yet, even here on these distant giants, we find beauty and wonder. Blue worlds with delicate rings and moons that hint at active pasts. They remind us that the spirit of exploration doesn't end at Saturn, but carries on to the farthest reaches, inviting us to marvel at what lies on the frontier of our sun's influence. Our final stop on this cosmic journey through the solar system lies even farther out, in the frozen twilight where the sun is but a distant spark. Here, we encounter Pluto and the myriad icy worlds of the Kuiper Belt, the frontier of the Sun's family. Pluto, once considered the ninth planet, is now understood as one of the largest members of this Kuiper Belt. It is a small, cold world, smaller than our moon, orbiting more than 5.8 billion kilometers from the Sun on average. From Pluto, the Sun is just a very bright star, providing a faint daylight that would look like perpetual early evening to our eyes. In 2015, the New Horizons spacecraft gave us our first close look at Pluto, and what it saw astonished us. This distant world is not a simple ice ball, but a dynamic landscape with surprising variety. Pluto has a broad, heart-shaped plain of nitrogen ice, informally called Tombor Regio, that is smooth and young, with no craters, evidence of recent geologic activity. Towering over the plains are mountains made of rock-hard water ice, some rising as high as 3 to 4 kilometers. Blue hazes ring Pluto, layers of a thin atmosphere that extends high above the surface and freezes onto the ground when Pluto moves farthest from the Sun. Despite the feeble sunlight and temperatures around 230 degrees Celsius, Pluto's surface is a canvas of light and dark patches, glaciers that slowly ooze, and perhaps even cryovolcanoes that once oozed icy slush instead of molten rock. Pluto has its own little system of moons. Charon, the largest, is so big, about half Pluto's diameter, that Pluto and Charon orbit each other like a double planet, pirouetting around a point in space between them. Charon's surface is covered in water ice and craters, with a mysterious reddish cap at its pole, possibly material captured from Pluto's atmosphere. The duo is locked in an eternal dance. Charon always shows the same face to Pluto, and Pluto to Charon, as they twirl through the darkness together every 6.4 days. Pluto has 4 smaller moons as well: Styx, Nix, Kerberos, and Hydra, tiny irregular bodies likely caught in this gravitational ballet. As we drift away from Pluto, we find ourselves in the broader Kuiper Belt. This is a vast ring of icy remnants from the solar system's formation, encircling the Sun beyond Neptune. It's populated by countless comet-like objects and dwarf planets. Pluto is one of several worlds here. There is Eris, slightly more massive than Pluto, discovered in 2005 and initially nicknamed Xena. Its finding prompted a redefinition of what a planet is. There are also Makemake, Haumea, with its elongated shape and ring, and many smaller bodies yet unnamed and unseen, except as faint points of light. The Kuiper Belt is like an ancient frozen attic of the solar system, preserving clues to how our planetary family formed. Every so often, one of these icy bodies is disturbed and falls inward towards the Sun, becoming a comet with a shining tail visible in our skies. Out here at the edge, the silence is profound, and the darkness nearly complete. The Sun's light is a feeble glow, and the warmth we know is gone. We are more than 6 billion kilometers from home. If you were to stand on Pluto's surface and look up, you would see a sky of black velvet, strewn with stars, unwavering by atmospheric twinkle. The Sun would be a tiny beacon, and around it you might just make out a thin halo of light. The combined glow of billions of distant comets and icy bodies in the Kuiper Belt and beyond. This is the threshold of interstellar space, where the Sun's domain fades into the cosmic gulf. From here onward, the distances become almost unimaginable. and the next nearest star is trillions of kilometers away. We take one last look back at the solar system from this frontier. The planets we visited, from Mercury by the sun's blazing furnace, all the way to Pluto's frozen twilight, now huddle near our faint sun like a tiny family gathering around a campfire in a dark, cold night. Beyond Pluto, a vast expanse stretches to infinity, filled with stars and mysteries. Our journey through the planets may end here, but the voyage into the wider universe is just beginning. With a gentle breath, we prepare to leave the sun's comforting glow and venture into the endless sea of stars that awaits beyond. Our spacecraft of the imagination drifts silently beyond the borders of our solar system, into the deep between the stars. Here, in interstellar space, the sun has faded to a distant point of light behind us, and ahead lies a darkness dotted only with faint, far-off stars. The space between star systems is peaceful and still, a vast, quiet expanse that seems almost completely empty. Yet even this void is not truly empty. It is filled with the thinnest of whispers, a few stray atoms of hydrogen drifting in each cubic centimetre, dust grains left from ancient stars, and the faint glow of starlight crossing light years of distance. In this great black sea, we are surrounded by an almost perfect silence. No planets circle nearby, no comet tails glow. We have left all familiar things behind. The temperature has dropped to only a few degrees above absolute zero. There is no up or down, no day or night, only the endless night of space stretching out in all directions. It is a realm of solitude and serenity. We feel ourselves floating in a true emptiness, a darkness so profound that it awakens a deep calm within. In this darkness, each pinprick star on the horizon becomes precious. We realize how far we are from home, and how vast the universe really is. The nearest star is over 4 light years away, so distant that its light has been travelling since before we learned to fly airplanes, just to reach us now. And beyond that star lie billions more. Here in interstellar space, we truly grasp the scale of our cosmic voyage. In the stillness, you might sense your own heartbeat and breathing as loud rhythms, for external sound has vanished. The nearest atoms outside are so sparse that collision is rare. The vacuum is almost perfect. You are suspended in an almost spiritual quiet. With nothing but starlight and the gentle hum of our imagined spacecraft systems, a contemplative mood arises naturally. What lies ahead between those stars, we wonder? The emptiness invites such reflection. It's as if the cosmos has given us a pause, a dark interval between the chapters of creation. In this pause, we remember that even here, seemingly in nothingness, we are still connected. The atoms within your body, the breath you just exhaled, will eventually drift out and mingle with this interstellar medium. And some of the sparse atoms out here may one day find their way into new worlds, or even into living beings yet to come. Nothing is truly isolated. Even between the stars, there is an invisible exchange. Occasionally, a wandering particle from a distant star's eruption zips past us, or a faint puff of gas from our sun's distant heliosphere boundary catches up. We might even imagine the lonely Voyager 1 probe, humanity's far-flung messenger, quietly coasting out here with its golden record, having said farewell to the solar system. It sails on through this ocean of night, bearing our greetings in dozens of languages, surrounded by silence. The thought of that brave little craft brings a comforting sense of companionship, a reminder that even as we float in this dark expanse, a piece of home travels with us. After a long interval in the starry void, a tiny beacon begins to grow ahead. The faint light of the nearest stars, our stellar neighbours. At first, it is just one point of light, slowly brightening against the black canvas. But as we draw nearer, in our mind's eye, perhaps accelerated by imagination's wing, it separates into two distinct stars, and then we notice a third, much dimmer companion. We have arrived at Alpha Centauri, the closest star system to our Sun. In reality, it would take tens of thousands of years with current technology to journey here. But in our story, we drift effortlessly, carried by curiosity. Alpha Centauri is a triple star. Two of its stars are much like the Sun, golden, steady, and warm. They dance around each other in a slow gravitational waltz, drawing closer and then farther apart over decades. The third star, called Proxima Centauri, is a small red dwarf orbiting its larger siblings at a great distance. Proxima is actually the closest star to Earth, aside from our Sun, at about 4.24 light-years away. From our vantage, we see the twin suns, Alpha Centauri, A and B, shining brightly, their combined glow illuminating any nearby space. They cast a gentle radiance on our ship's hull, a light not unlike the sunshine we know, since these stars are siblings of our Sun in type and colour. Proxima Centauri, in contrast, is a faint ember off to one side, a cool red-hued star that barely outshines the background stars. If we peer at Proxima closely, we might see it flare now and then. Red dwarfs are known to flicker with sudden bursts of energy. Seeing these stars up close, we are struck by a profound realization. The stars truly are other suns. Around us, in every direction, each star we glimpse could be the center of its own solar system. Our Sun is not unique. It is one among countless others, and here before us is the nearest example of another sun with possible worlds of its own. One of Alpha Centauri's two bright stars is slightly larger and hotter than our Sun, and the other slightly smaller and cooler, but both would shine brilliantly white-yellow in a nearby planet's sky. If there were an Earth-like world orbiting Alpha Centauri A or B, imagine the scene. Two brilliant suns might grace its daylight sky. One blazing overhead, the other a bright point a little farther off, perhaps offering twin shadows at certain times. During parts of the orbit, the two suns would set hours apart, giving extended daylight or exquisite double sunsets of gold and orange. How alien and beautiful such a sky would be. As we float here, we cannot see any planets with our naked eyes, but our instruments and imagination tell us they could be present. In fact, astronomers have long searched the Alpha Centauri system for planets and have found hints of small worlds. We turn our attention to Proxima Centauri, that dim red star, for it harbours at least one known planet. This planet, called Proxima b, is at least roughly Earth-sized and orbits within what we might call the habitable zone, where temperatures could allow liquid water. It's tantalizing to think that the very closest star to our Sun has a potentially Earth-like planet. If we approach Proxima b in our imagination, what might we find? The star Proxima is much smaller and cooler than the Sun, so at noon its light would be more ruddy, as if the sky is in perpetual sunrise or sunset. Standing on Proxima b, if it has a solid surface, You might see Proxima Centauri hanging in the sky as an immense dusky red orb. The star likely emits flares of radiation periodically, meaning the environment could be harsh. But perhaps the planet has a thick atmosphere or ocean to shield life, if life exists there at all. If you were a traveller on that world, you'd see something marvellous in your night sky. Far away, the twin suns of Alpha Centauri A and B would appear as a single bright star, a golden point much brighter than any star appears from Earth. And not far from it in the sky, a small, unremarkable star twinkles. That's our Sun, as seen from Proxima b. In such moments, we appreciate the reciprocity of perspective. Just as we wonder about inhabitants of distant planets, looking up at their stars, anyone out there with eyes to see could wonder about the warm star that we call the Sun. For now, we do not know if any conscious beings orbit these stars, but simply knowing that planets exist around them makes the universe feel a bit more intimate. As if the lights in the houses of our cosmic neighbourhood are turning on, one by one, revealing that we have neighbours, even if we haven't met them. Beyond Proxima, we continue our journey outward, visiting in our thoughts some of the exoplanets, worlds around other suns that human ingenuity has discovered. In the past few decades, astronomers have confirmed the existence of over 5,000 exoplanets, and the number grows all the time. Imagine 5,000 other worlds, and those are just the ones we've found with our still young techniques. The mind reels at what they might be like. Let us drift to one of these exotic places. We set course for a star a bit further away, and with the blink of an eye, we arrive at a sun not too different from our own. Circling this star is a giant planet, even larger than Jupiter, but it hugs the star in a tight orbit, so close that its atmosphere is blazing hot. This type of world is called a hot Jupiter. As we pass by it, we see roiling clouds, and perhaps a comet-like tail of gas being blown off by the star's heat. The planet's day side glares yellow-white from reflected starlight, while the night side, though dark, might glow dull red from its own heat. Such a planet is nothing like any in our solar system. It challenges our notions of how planetary systems form. We marvel at the variety the cosmos produces. We move on to another system, far across the galaxy, where a small red dwarf star is orbited by a family of 7 rocky planets. This is the famous TRAPPIST-1 system. In our journey of the mind, we can be everywhere at once. So now, we find ourselves among these tightly packed worlds. Some of them are in the star's habitable zone. Because the star is dim, the planets must orbit very close to get enough warmth. Thus, they all lie near each other. On the surface of one of these planets, a coppery red sun looms huge in the sky, and you might glimpse neighbouring planets as sizable crescents hanging above the horizon. One planet could show a bluish tint, perhaps an ocean world. Another might be rust-coloured. If life exists on any, they might even see each other's atmospheres or glints of water by telescope, sister worlds in eternal companionship. The idea of multiple inhabited planets in one system is enchanting. Perhaps travellers could hop from one to another in the far future, experiencing different versions of alien beauty around the same star. Now we glide to yet another strange world, a rogue planet, drifting alone without a star. Yes, not all planets belong to a solar system. Some are orphaned, likely ejected during their system's formation or when passing near other stars. In the pitch blackness of interstellar space, we detect one such planet by its faint heat glow in infrared. We approach it and find that it is a Jupiter-sized world shrouded in thick atmosphere. There is no day or night here, only eternal night. Yet it might not be entirely dead. Gravitational contraction or radioactive elements might warm it from within, and who knows, it could have clouds, even rain of liquid natural gas, forming alien weather under starlight that is 1,000,000 times fainter than on Earth. This lonely world emphasizes how diverse and surprising planets can be. Some exoplanets have been found with 2 suns, like the fictional Tatooine, but real. Some likely with rings far larger than Saturn's. Some with skies tormented by perpetual storms larger than Earth. Our journey barely scratches the surface of these discoveries. But each new world we imagine is a tribute to the cosmos's boundless creativity. As we revel in the diversity of worlds, a gentle realization dawns. Every star we see likely hosts planets, and thus the universe may be filled with far more planets than stars. The odds that we are entirely alone diminish with each new discovery. Under some alien sun, on some remote exoplanet's shore, perhaps an ocean sighs against strange rocks, and something living, however simple, stirs in that salty water. We do not know, but the possibility itself is wondrous and comforting. It means the story of life could be a cosmic story, not just an Earth story. With that comforting thought, we journey on. Leaving these star systems behind, we set our sights on a faint glow in the distance. Not the light of a single star, but the diffuse, colourful glow of a vast cloud of gas and dust. We are approaching a nebula, a stellar nursery where new stars are being born. As we draw near, the scene lights up with ethereal beauty. Imagine the Orion Nebula, one of the closest star-forming regions to Earth, about 1,300 light-years away. To the naked eye from Earth, Orion Nebula appears as a small fuzzy patch in Orion's sword. But up close, it is an immense cloud spanning dozens of light-years. Here it looms before us like a billowing heavenly canvas, glowing in pinks and blues. The nebula's gas is illuminated from within by bright newborn stars that have recently ignited and are now carving out cavities in the gas with their intense radiation. We drift into the nebula's outer fringes and find ourselves surrounded by a soft luminescence. Tendrils of tenuous gas, mostly hydrogen, waft around us like gossamer curtains. Dense, dark globules, knots of dust, pepper the glowing backdrop like ink blots on a pastel painting. These are Bok globules, cocoons where protostars hide, not yet visible. We venture deeper, dodging gently around a region where the glow intensifies. A cluster of massive young stars, known as the trapezium, in the heart of Orion Nebula, shines with fierce white-blue light. These stars are only a few million years old, infants by stellar standards, and they burn hot and bright. Their ultraviolet rays excite the surrounding hydrogen gas, causing it to fluoresce in that characteristic pinkish-red hue of nebulae. Oxygen and other elements contribute blue-green and other tints, making the nebula a cosmic work of art. The sight is breathtaking. Pillars and columns of gas, sculpted by starlight, rise like stalagmites in a cave, crowned with bright starry jewels. Some columns hide embryonic stars in their tips, as captured famously in the Pillars of Creation image in a different nebula. Here too, in Orion, we have our own pillars and ridges, where gravity gathers material into ever denser clumps. We come upon one such region, a denser pocket of gas. It's cold here, just a few tens of degrees above absolute zero. Deep inside this cold cloud, something miraculous is happening. Gas and dust, drawn together by gravity's patient pull, are collapsing into a rotating disk. In the center of that disk, pressure and temperature rise inexorably. We are witnessing the birth of a star. The protostar, at the center of this disk, is still shrouded, not yet hot enough to emit visible light. But as the gas falls in, it heats up and glows in infrared, and we sense the warm embrace of a star about to be born. If we wait a few 100,000 years, a blink in cosmic time, this protostar will gather enough mass and reach high enough temperatures in its core to ignite nuclear fusion. Then a new star will burst forth, blowing away the cocoon of dust with a newborn stellar wind, and taking its place among the shining population of the nebula. But the wonders do not stop there. Around that young star, the remaining disk of gas and dust may coalesce into planets. We are essentially seeing a snapshot of how our own solar system formed some 4.6 billion years ago, inside a similar nebula long dispersed. It's humbling and exciting to think that our Sun and Earth were once parts of a dense nebula cloud, which gave birth to many siblings. Perhaps some meteorites or comets in our solar system still carry grains from that ancestral nursery. All around us in this nebula, stellar nurseries are at work. We imagine time sped up. You would see stars winking on like fireflies as more protostars ignite. The most massive of them live fast and die young, even within the same nebula's lifetime, perhaps exploding as supernova that trigger the next round of star formation. The smaller ones, like our Sun, will have longer, steadier lives. As we float here, taking in the cosmic cradle, a sense of renewal fills our hearts. Nebulae like this ensure that the galaxy continues to teem with new stars and planets. They are the wombs of creation in the universe, recycling material from old stellar generations into new opportunities for light and life. We leave the Orion Nebula with reluctance, its silent fireworks of creation imprinted in our memory. From the tumult of birth, we move on to consider the long tale that follows, the life of stars. Every star, once born, embarks on a life cycle determined largely by one factor, its mass. We find ourselves now drifting alongside a stable star, perhaps not unlike our own Sun, but a bit younger. It shines a gentle yellow-white, its surface seething with convection cells and occasional flares. This star is in the long middle chapter of its life, a phase called the main sequence. Like the Sun, it has found a balance. The inward pull of gravity is exactly counteracted by the outward pressure of energy produced by fusion in its core. In that core, hydrogen nuclei are fusing into helium, releasing tremendous energy that makes the star shine and supports it against collapse. A star in this phase is remarkably steady. Our Sun has shone for about 5 billion years and will shine about 5 billion more in this manner. For a star, this main sequence life is rather like the adulthood of a person. Stable and long compared to the dramatic birth and eventual demise. Not all stars have the same temperament. We look around and notice stars of many colours. Blue-white stars, extremely luminous and large, dot the sky in a scattering. These are high-mass stars, many times more massive than the Sun. They burn their fuel at a prodigious rate. Their core temperatures soar, and they emit a fierce, bluish light. They are the sprinters of the stellar world, brilliant but short-lived. A blue supergiant might last only a few million years before consuming its core's hydrogen. Meanwhile, red dwarf stars, small and cool, are like the marathon runners. A red dwarf, far less massive than the Sun, burns its fuel so slowly that it can live for hundreds of billions or even trillions of years, far longer than the current age of the universe. These little stars glow a ruddy crimson or orange colour and are often quite dim, and yet they are the most common type of star in our galaxy by far. If you were near one, up close, its red light might feel warm and comforting, but you would need to be quite near to get the amount of light Earth gets from the Sun. We think perhaps of Proxima Centauri again, such a red dwarf, destined to outlive our Sun by eons, though its habit of flaring is potentially hazardous for life. Through the diversity of stars, one thing remains true. They are all sustained by the same simple process of fusion, turning light elements into heavier ones and releasing energy. In doing so, they slowly transmute part of their mass into the light and warmth they give off. A star is rather like a candle in that sense, burning its fuel to shine. But no candle burns for billions of years. Stars can because they are so massive and dense in their cores that nuclear reactions proceed at just the right balanced rate. For a long time, an outsider would notice very little change in a star like our Sun. But nothing in this universe is truly eternal. Eventually, even the main sequence phase ends when the core runs low on hydrogen. We now gently accelerate time to witness what will happen to a star like our Sun. Eons pass in moments. After about 10 billion total years of shining, the hydrogen in the core of our Sun-like star is nearly exhausted. The delicate balance tips, the core, now mostly helium ash with no fusion to support it, begins to contract under gravity. As it contracts, it heats up, and the shell of hydrogen around the core ignites in fusion, actually causing the star's outer layers to expand enormously. The star swells into a red giant. We find ourselves looking at our once modest star transformed into a bloated giant many dozens of times its previous diameter. Its surface has cooled due to expansion, so it glows with a cooler, reddish hue now, hence the term red giant. If this were our Sun, its expanding girth would likely engulf the innermost planets. Mercury and Venus would be swallowed up. Earth might or might not be engulfed. Scientists aren't certain. But either way, the Earth's surface would be scorched lifeless by the Sun's intense heat at this distance. But this cataclysm is billions of years away, far beyond the span of our species, or even mountains and oceans as we know them. Standing here now in our mind's journey, the swollen star looks both beautiful and a bit ominous. Its once steady light now fluctuates gently, as many red giants are variable stars. You can imagine the sky of any surviving planets or moons further out. This enormous red sun dominating the sky, perhaps taking up a quarter of the sky, glowing a dark orange-red, bathing everything in a sunset-like light. Inside the core of this red giant, remarkable events occur. The core, now extremely compressed and hot, hundreds of millions of degrees, finally ignites helium fusion. In a flash, literally called the helium flash in stellar physics, though from outside it might not be visible. The star begins fusing helium into carbon and oxygen. The star stabilizes for a while, shrinking slightly from its most swollen state, but it remains a giant. This helium-burning phase is shorter-lived. When helium runs out, the core contracts again. For a star like our Sun, it does not have enough mass to fuse carbon. The fusion process stops at that point. What happens next is a gentle unraveling. The outer layers of the star, no longer tightly bound, drift away into space. The star sheds its skins, layer by layer. What remains of the core, incredibly dense and hot, illuminates those drifting layers from within. The result is one of the most exquisite sights in astronomy, a planetary nebula. Despite the name, planetary nebulae have nothing to do with planets. The term came from their round appearance in early telescopes. Now we are witnessing one up close. The red giant stars' cast-off layers expand outward in a series of shells. They form glowing, ethereal shapes around the dying star. No two planetary nebulae look exactly alike. Some are spherical halos, some are bipolar lobes like cosmic hourglasses, some resemble butterflies or delicate rings. The colours are vivid, often a greenish blue from oxygen, reds from hydrogen, sometimes purple hints from nitrogen. We drift through the edge of such a nebula and see the filigree of gas, like a lacework puffball, illuminated by the brilliant hot core at the centre. That core is now a white dwarf, the final state of a sun-like star's heart. It is a stellar ember, roughly the size of Earth, but with mass about half that of the Sun. It's incredibly dense. A teaspoon of white dwarf material would weigh tons on Earth. And extremely hot at first, shining white blue. Over billions of years, this white dwarf will cool and fade, eventually becoming a cold, dark, stellar remnant, sometimes poetically called a black dwarf, though none have had time to cool that far yet in the age of the universe. For now, the white dwarf is a beacon, and the planetary nebula around it is expanding and cooling. We take in the serene beauty of this gentle farewell of a star. In our galaxy, there are many planetary nebulae, the remains of countless stars that quietly ended their lives this way. Our own Sun will create one, perhaps a subtle glowing shell, that future alien astronomers might observe long after Earth is gone. There is something deeply moving in this. The matter that was once the star's outer layers, which for so long provided warmth and light to any orbiting worlds, is returned to space, where it will mix with other gas and maybe one day be part of a new nebula, forming new stars. We are reminded of a saying, "We are all stardust." Here before our eyes is the process that makes that true. Stars enriching the cosmos with heavier elements and dust as they die, the very elements that will go into the next generation of stars, planets, and life. The carbon and oxygen created in the helium-burning core now flow out into space with the nebula, ready to become part of new cosmic stories. This red giant's final sigh spreads the ingredients for future roses, future butterflies, maybe future minds. Yet not all stars go so gently into that good night. Our journey now takes a more dramatic turn as we seek out the spectacular cosmic endings of the most massive stars, the titanic supernovae and their exotic remnants, neutron stars, and sometimes black holes, which we'll explore fully soon. We set course towards a massive star that is nearing its end. Perhaps it is the bright blue star we glimpsed earlier, one that formed in a nebula only a few million years ago, but has already lived its main life and moved to giant status. We arrive in time to find it as a red supergiant, an even larger cousin of the red giant, swollen to astonishing size. Think of the star Betelgeuse, the bright red shoulder of Orion. Betelgeuse is a red supergiant, roughly 700 times the Sun's radius. If placed in our solar system, it would extend to the orbit of Jupiter. Such a star is cool on the surface, hence red, but its sheer size makes it extremely luminous. Betelgeuse is expected to go supernova within perhaps the next 100,000 years. In our imagination, we now witness a star like Betelgeuse reaching the final moments of its life. Inside a supergiant star, the fusion story has gone further than in small stars. After burning hydrogen to helium and helium to carbon and oxygen, a massive star continues. It fuses carbon into neon, magnesium, and sodium, then heavier elements like silicon, sulfur, and so on. These phases go faster and faster as the star desperately tries to support itself. Finally, the core is composed of iron, and iron fusion does not yield energy. Instead, it consumes energy. This is the final dead end. The star's core is like an ash that can no longer burn to stave off gravity. At that moment, the balance that held the star up is catastrophically lost. In less than a second, the iron core, about the size of Earth perhaps, collapses under its own weight. Protons and electrons in the core are crushed together into neutrons with a burst of neutrinos. The core, now essentially a ball of neutrons, stiffens abruptly. Neutrons resist further compression fiercely. The infalling outer core slams onto this neutron core and rebounds. What follows is one of the most violent events in nature. A core collapse supernova. We, as observers, would see the star suddenly brighten millions of times over in a titanic explosion that briefly outshines all other stars in its galaxy. In a split second, a shockwave rips through the star's layers, blowing them into space at thousands of kilometers per second. We stand at a very safe distance, mind you, in awe as the star we were watching literally tears itself apart. The darkness of the cosmos around is lit by a new furious light. If we had been in a nearby solar system, the night would suddenly turn into an eerie day as this new star flared. On Earth, ancient observers witnessed such events as guest stars that appeared suddenly. The Crab Nebula, for example, is the remnant of a supernova seen by humans in 1054 AD, recorded by Chinese and other astronomers. They saw a star that wasn't there before, shining in the daytime sky for weeks. Now we witness the phenomenon up close, the death of a star in a supernova. It's a mix of terror and beauty, immense destructive power, yet it is also a creative act in the grand scheme. The explosion is forging new elements: gold, silver, uranium. All heavier elements beyond iron are synthesized in these fleeting moments of fury. And all those elements, along with the stellar material, are now cast out into space, enriching the interstellar medium. This is the source of much of the iron in your blood and calcium in your bones. Long ago, supernovae scattering the ingredients that would one day form our sun and planets. As the glare subsides over weeks and months, what is left behind? We approach the center of the expanding debris cloud, now a brilliant supernova remnant, like the Crab Nebula's beautiful filaments of orange and blue. Inside, at the very heart, lies the collapsed core, now a neutron star. We find this tiny object, perhaps only 20 kilometers across, spinning rapidly and emitting beams of radiation. It is a pulsar, a rotating neutron star that sends lighthouse-like beams sweeping through space. As we move cautiously closer, the gravity around this object is intense. A neutron star packs more mass than the Sun into a sphere the size of a city Its surface gravity is so strong that if you dropped a pebble from 1 meter above, it would hit the surface in a microsecond and be moving at thousands of kilometers per second. The physics here is extreme. Matter is in a state we don't encounter elsewhere. Essentially a giant atomic nucleus made mostly of neutrons. Yet in this exotic death, there is a kind of strange life. The neutron star is active, with a powerful magnetic field. If charged particles from the environment fall onto it, the neutron star accelerates them and produces radiation. Pulsars often emit in radio waves. When discovered, the regular blips of radio emission were so precise that scientists humorously dubbed the first one LGM for Little Green Men, thinking perhaps it was a signal. But it was nature's signal, a spinning neutron star sending out pulses every rotation. We watch as this pulsar spins maybe dozens of times a second. Some spin hundreds of times per second. Each spin, a beam of light sweeps past us. Flash, 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 like a cosmic heartbeat. It's strangely comforting in its regularity, even though it's a remnant of violence. If we tune our craft's instruments to radio, we might hear it as a steady series of ticks. The Crab Nebula's pulsar, for instance, beats about 30 times a second. This tiny star remnant will gradually slow down over millennia, but it will remain perhaps for billions of years, slowly cooling. Some neutron stars, instead of becoming pulsars, might simply cool into obscurity if they don't have strong magnetic fields or rotation. Others, if they are in close orbits with another star, can accrete matter and create energetic X-ray emissions, X-ray pulsars, or even merge with another neutron star in an event that sends gravitational waves across the universe. However, our journey must note, if the original star was even more massive, more than say 20-30 times the Sun's mass, even the neutron star solution might fail. The core collapse in those cases might produce not a neutron star, but a black hole, as gravity overwhelms all resistance. We will now turn to those most enigmatic of cosmic objects. Black holes. Gravity's abyss. To find a black hole, we actually can't see it directly. It emits no light. But we infer its presence by its effects. One likely place is in a binary system, where we see a star orbiting an unseen partner that has too much mass to be anything but a black hole. Let's imagine such a scenario. We arrive at an X-ray binary system, a normal star and an invisible companion locked in orbit. The normal star is losing gas from its outer layers, drawn into a swirling disk around the void where the companion is. As this gas spirals inward, much like water down a drain, it heats up to extreme temperatures and emits X-rays. The intense gravity accelerates the gas to a significant fraction of light speed near the center. We focus on that dark center. There lies a stellar mass black hole, perhaps 10 times the Sun's mass, compressed into a sphere maybe only 60 kilometers across, the size of a small city. This is the event horizon, the point of no return around the black hole. Space and time themselves are so warped by gravity here that nothing, not even light, can escape once it crosses that boundary. Hovering at a safe remove, we watch the accretion disk's inner edge. The gas glows bluish-white and then ultraviolet, then X-ray as it vanishes from view beyond the horizon. Occasionally, blobs of hot plasma shoot out along the black hole's poles in jets, a byproduct of magnetic and rotational effects in the disk. It's a mesmerizing but dangerous beauty. If we were to move too close, our ship would experience the infamous tidal forces, a stretching pull that could be fatal. But from here, we can marvel. The black hole itself is invisible. Instead, we see a sort of gravitational mirage. Light from the far side of the accretion disk is bent around the black hole, so we see a circle of light, the so-called photon ring. It's as if the black hole wears a thin halo of light, an echo of the devoured matter. This phenomenon was actually imaged for a supermassive black hole in another galaxy, and for the one in our own galactic center, appearing as a bright ring surrounding a dark shadow. We ponder the nature of this abyss. If one were to fall in, from their perspective they'd pass the event horizon and inevitably reach the central singularity, where density is infinite in our equations, likely getting destroyed along the way. But to a distant observer like us, that object falling in never quite appears to cross the horizon. It gets redder and dimmer and seems frozen at the edge due to time dilation. Time near the black hole stretches almost to a stop relative to far away. This is truly a break from everyday reality, a region where our intuitions fail, and only Einstein's general relativity and beyond can describe what happens. Some black holes spin, dragging space-time around with them. Some have charge, etc. But regardless, inside that boundary, all paths lead inward. For all their fearsome reputation, black holes play an important role in the cosmos. They are the ultimate garbage disposals and engines of transformation. When black holes merge, they send ripples, gravitational waves, that we can detect with instruments like LIGO, literally listening to the vibrations of space itself from billions of light years away. And at the centers of galaxies, supermassive black holes millions or billions of times heavier than the sun lurk, sometimes powering quasars if actively feeding. We will soon visit our own galaxy's center where one resides. But here, reflecting on this stellar black hole, we find it oddly peaceful to watch from afar. The concept that such a thing exists stretches our mind. One might find a poetic parallel. Just as there are places in the human psyche that feel like inescapable darkness, yet from those depths, creativity or understanding can spring like the jets from a black hole. In the universe, the deepest gravity wells create some of the brightest displays. Quasar jets, X-ray emissions. It's as if the universe ensures that even in collapse, energy and light can find a way to escape into the broader cosmos to be reused. We leave the vicinity of the stellar black hole now and decide to take a grander view. Our journey so far has been among stars and nebulae mostly within our cosmic neighborhood. Now we pull back further, traveling a great distance out of the galactic plane so that we can behold the Milky Way, our home galaxy, in its full glory. As we rise above the disk, an awe-inspiring panorama unfolds. The Milky Way is a majestic spiral galaxy, a flattened disk with curving spiral arms wrapped around a bright central bulge. From our vantage point outside it, the galaxy looks like a huge, shimmering whirlpool of stars, tens of thousands of light years across. The spiral arms are not solid structures, but density waves, like traffic jams of stars and nebulae orbiting the center. They are outlined by bright young stars and nebulae. Along the arms we see knots of pink where new stars are forming, just like the Orion nebula we visited, only many more, and clusters of blue stars that have recently formed and light up their neighborhoods. Between arms, the star density is a bit lower and the population older. Dark ribbons of dust thread through the disk, obscure lanes that block visible light and create the mottled band we see from Earth on a dark night. That band, the Milky Way, as seen from within, is actually the combined light of billions of distant stars in the disk. Their light diffused into a cloudy band by distance and dust. Now, from outside, we see those same stars resolved into their grand structure. The Milky Way's central bulge is a more spheroidal concentration of older, yellower stars surrounding the very core. Extending above and below the disk are tenuous halos of globular clusters, spherical clusters of very old stars, and an invisible halo of dark matter that far outweighs the visible stars. The dark matter halo is inferred by the galaxy's rotation speeds. We cannot see it, but it forms the scaffold in which the visible galaxy sits. As we look at the galaxy, we realize we are looking at roughly 100 to 400 billion stars. It's a number too large to truly fathom. If each star were a grain of sand, the Milky Way's stars would fill countless beaches. If each star were a second of time, 100 billion seconds is over 3,000 years. It's humbling beyond words. And around those stars, as we considered, there may be even more planets, perhaps trillions. Somewhere in that immense ensemble is a rather ordinary star, about 27,000 light-years from the centre, in one of the minor spiral arms, the Orion arm. That's our Sun, utterly unremarkable among this sea of stars, yet precious to us beyond measure. It strikes us how homey and small our solar system is compared to the Milky Way, yet how the Milky Way is just home enough to make us feel we belong in the cosmos. Picture the Milky Way's spiral pattern slowly rotating. It takes on the order of 250 million years for our Sun to make one orbit around the galaxy. In the time since the dinosaurs first walked the Earth, the Sun has barely completed one circuit. From our godlike external perspective, we might speed up time and watch the arms sweep. New stars twinkle on, old ones explode off. The Milky Way would look alive in slow motion, breathing and evolving. Galaxies even collide and merge over eons, but ours is relatively isolated, except for some small satellite galaxies it's consuming gradually. The Magellanic Clouds, for instance, are interacting with the Milky Way. As a luminous being swirling in the dark of intergalactic space, our galaxy is beautiful. We might even see another spiral nearby, our big sibling, the Andromeda Galaxy, a bit larger than the Milky Way, about 2.5 million light-years away. It appears as a faint smudge in Earth's sky, but from here, with our enhanced vision, Andromeda is a full spiral disk facing us. It looks similar in majesty. Someday, billions of years from now, Andromeda and the Milky Way will merge into one. But that is a story for another night. Tonight, we focus on our Milky Way, and in particular we are drawn to the galactic center, the core of our galaxy where a great mystery resides. We zoom back in now, diving toward the Milky Way's center, toward the bright central bulge. As we approach, the density of stars around us increases dramatically. In the outer galaxy, like where our Sun is, the nearest star is over 4 light-years away, which is typical. But here in the inner regions, stars can be only a fraction of a light-year apart. The night sky on a planet near the galactic center would be like a jeweled tapestry. So many brilliant stars that night might never be truly dark. In every direction, close suns would burn. We have arrived in the nuclear star cluster, a packed region of millions of stars within just a few light-years of the true center. the light is dazzling. Many of these central stars are young and massive, others are old red giants. The environment is bathed in intense radiation and magnetic fields. We navigate carefully among them, approaching the very heart. We know from astronomical studies that at the exact center of our Milky Way lies a supermassive black hole named Sagittarius A star. It's about 4 million solar masses concentrated into a region that, before recent imaging, was unseen except for the motions of stars around it. We recall a remarkable feat of observation. Over decades, astronomers tracked individual stars orbiting an invisible point in the center of the Milky Way. These stars whipped around at incredible speeds, some moving at a few % of light speed at closest approach. Only a very massive, very compact object could cause such orbits. That's how we knew Sagittarius A is a black hole. And in 2022, the Event Horizon Telescope collaboration released an image, a ring of radio light, indirect, but still a portrait of this hidden giant. Now, in our journey, we're going to imagine we can actually see near Sagittarius A. The black hole itself is, of course, dark, but around it, just like around the smaller one we visited, there may be a disk of superheated infalling gas. Sagittarius A is relatively quiet now. It's not consuming much matter actively, so its accretion disk is not as bright as a quasar's. But occasionally, as it snacks on a clump of gas or a stray star that ventured too near, it emits flares of X-rays. We approach during a quiescent time, seeing only a faint glimmer around the black hole. Surrounding the black hole, out to a few light years, is a swarm of stars. We float in that region, mindful of the gravitational forces. The black hole itself, though huge in mass, is only about as large as Mercury's orbit in diameter, roughly 40 million kilometers across the event horizon. That's small compared to the solar system scale swirl of stars around it. So we could, in theory, orbit Sag-A at a safe distance and observe. We watch one star in particular, known as S2, which has been observed from Earth. It approaches as close as 17 light hours to the black hole, about 3 times the distance of Pluto from our Sun, and slingshots around at a blistering 2% the speed of light, completing an orbit every 16 years. We ride alongside S2 at its closest approach. Space itself feels differently curved here. Starlight from behind the black hole is bent, and the massive object's gravity redshifts S2's light as it climbs away from the periapsis. S2 swings away successfully, but if a star ventured even closer, it might be torn apart by tides, feeding the black hole a meal of stellar debris. In this extreme environment, we marvel that even here, stars have formed and survived. It's a crowded, energetic city at the center of our galaxy, quite unlike the quieter suburbs we call home. And at the core of it all, the dark colossus sits as a silent engine, affecting everything with its gravity, yet being strangely inconspicuous until something comes very near. In some galaxies, the central black holes are actively accreting and blazing as quasars, but ours is comparatively gentle now, flickering only occasionally. Perhaps that's fortunate for us, as a very active galactic nucleus can bathe a galaxy in harsh radiation. For a moment, let's imagine we could safely cross the event horizon of Sagittarius A just to ponder the unknown. If one fell in, according to general relativity, one could never communicate out again. Time and space swap roles, and all paths lead to the singularity at the center. What lies beyond that singularity, if the concept of beyond even makes sense, is unknown. Speculative ideas of wormholes or baby universes exist, but none proven. It's likely the end of the road for any infalling matter or information as far as our universe is concerned. The thought is heavy with mystery. Black holes are like punctuation marks in the story of the cosmos. Places where the known laws reach a limit and something new might be required to describe reality. We choose not to plunge inside, respecting the one-way nature of that boundary. Instead, we orbit a while longer around the galactic center, gazing outwards now from this vantage point. From here, the rest of the Milky Way encircles us. We see the long lanes of stars and dust extending outward, gradually thinning into the spiral arms where we came from. If we look towards the constellation, Sagittarius, from Earth's perspective, that's the direction of the core, but from here, every direction is outwards. We see what on Earth is the richest star clouds of the Milky Way's central bulge. They are all around us now. It's glorious and overwhelming. There are clusters here with hundreds of thousands of stars, like the Arches cluster, and exotic systems like binaries containing neutron stars or black holes, plus likely countless planets. It is a crowded, bustling cosmic hub. Having travelled from the quiet, interstellar darkness into this bustling galactic downtown, we reflect on the journey as a whole. We have traversed distances so great and seen changes so profound that the mind struggles to contain it all, from the silence between stars to the glow of neighbouring suns, from alien planets to stellar wombs, from the calm middle life of stars to their explosive deaths, and finally into the mystery of black holes and the grandeur of our galactic heart. Each step of the way, the universe has shown us new wonders and also new questions. And through it all, one thread keeps emerging. Everything is connected. The emptiness of interstellar space connects star systems through subtle flows of matter and gravity. The nearest stars share with us the fabric of the galaxy, and perhaps even exchange material, as hinted by comets or rogue asteroids swapping between systems. Exoplanets show that planetary systems are a common outcome of star formation. The story of our solar system is not unique, but part of a larger narrative of worlds. Nebulae tie into that as the origin of stars and the recipient of their ashes. They are the bookends of stellar life. The life and death of stars distribute elements that become the building blocks for planets and beings like us. We saw that clearly from the forging of iron in a star to its presence in our blood. The extremes of supernovae and black holes, while dramatic, loop back matter and energy into the galaxy's cycle, or hide them in gravitational vaults that challenge our physics. And on the grand scale, our Milky Way is an ecosystem of all these processes, with the central black hole perhaps playing a regulating role in the galaxy's evolution. When active, it could limit star formation by its energy output, etc. All of it is one vast story, and we are part of it. As we drift away now from the galactic center, heading once again to a more serene spot where we can simply look and reflect, we realize that by understanding these cosmic phenomena, we also come to understand ourselves better. We see how ancient events made life possible. A supernova had to seed our solar nebula with heavy elements so Earth could have a rocky surface and water and life's chemistry. We see how the cosmic neighborhood protects or threatens us. Nearby supernovae could affect Earth's biology, Some speculate past extinction events might link to them. And our sun's travel through the Milky Way might expose us to varying cosmic environments. But mostly, we see how precious and perhaps rare it is to have a calm, stable corner, like we do for life to flourish over billions of years. In the galactic center, conditions might be too extreme for life as we know it. Out in interstellar space, life's raw materials might be too sparse. But in the galactic habitable zone, where we reside, things are just right for now. It's a reminder that while the universe is hospitable to life in principle, it also requires a delicate balance of factors. A Goldilocks zone, not just around a star, but perhaps in a galaxy too. Our spacecraft of the mind now carries us gently back toward our solar system, leaving the bright core behind, retracing the spiral arm outward. The stars thin out somewhat. The familiar constellations begin to appear as we reach roughly the sun's neighborhood. We recognize patterns of bright stars that from Earth make the figures of myth. Orion, Scorpius, the Southern Cross, if we go south. It's as if returning home from a long voyage and seeing the outline of your town's skyline come into view. Earth is there, a tiny blue dot orbiting its yellow star, which now regains its identity as the sun, warming hearth of humanity. We have been gone in imagination, perhaps mere hours, but traversed tens of thousands of light years in scope. As we slip back into the vicinity of our solar system, we feel a sense of belonging and relief, much as a traveller might feel upon seeing their home port after long at sea. Yet we carry with us the vastness we've experienced. Even as you settle back into the comfort of the familiar, you realize you will never look at the night sky the same way again. When you gaze up and see that misty band of the Milky Way, you'll know it's not a cloud. It's the combined light of uncountable stars, including that busy galactic center hidden behind dust. When you see a red star, you might wonder if it's a red giant, nearing its gentle end, or a red dwarf that will outlive everything else. The point of light might be an entire star system, with planets and maybe life. The space between stars, which looks like nothing, you'll know is a quiet bridge, not completely empty, but filled with faint whispers that connect stars over time. Our journey through the cosmos has carried us across countless wonders. Luminous, ethereal nebulae and swirling galaxies and distant worlds. Now, as we drift further into the quiet, star-washed reaches of space, a gentle cosmic silence surrounds us. The stars glimmer like distant lanterns set in a deep velvet expanse, and the band of our Milky Way galaxy arches overhead like a faint, glowing river. With no sound but the beating of our hearts and the whisper of our own thoughts, we feel truly afloat in the cosmic ocean. In this stillness, the vastness and mystery of the universe invites a deeper, more contemplative reflection. We find ourselves not just observers of the stars, but participants in a grand cosmic story, entwined with the very fabric of the night sky. Beneath an endless vault of stars, a sense of cosmic consciousness awakens. It is a subtle awareness that we, who gaze up at the galaxies, are made of the same luminous dust that twinkles above. The atoms that form us were born in ancient stars, and in our minds flickers the light of those long-vanished suns. We are more than small beings lost in the void. We are the universe itself, perceiving its own immensity through human eyes. On a moonlit night, far from city lights, one can lie back on cool grass and feel the infinity overhead. The Milky Way, spills across the sky, and in its silvery glow comes a whisper of connection. Each star above is a distant sun, and around some of those suns may circle planets with their own seas and skies. Perhaps on a faraway world, under an alien sky, another soul looks up and feels the same wonder. They might have two moons, or a sky tinted in unfamiliar colours, but the stars above spark a familiar question in their heart. In their own way, they wonder if someone else is out there, just as we wonder about them. For that distant observer, we are part of the mystery of the universe, just as they are for us. In that thought, the cosmos seems to grow smaller and more intimate, like a neighbourhood of houses under one shared sky. We do not yet know whether such distant neighbours truly exist. The universe is silent so far about other beings. If, in the vastness of space, we are the only ones who have awakened to awareness, then our role is singular and profound, to be the universe's lone conscious voice, cherishing that gift of insight. If, on the other hand, the cosmos is teeming with life, then one day our awareness may meet another's, and the universe will know itself in a new, collective way. Either possibility fills the heart with wonder. In the meantime, the night sky keeps its quiet secrets, and we continue to send out our thoughts and probes as greetings in the dark. With each message and each listening ear turned skyward, we affirm hope that we are not alone. And even if we are, the cosmos we are a part of is rich enough in marvels to keep us company. This feeling of unity can arise in quiet moments. As you inhale under the night sky, the air filling your lungs carries atoms exhaled by trees and ancient forests, atoms that have drifted through clouds and across oceans to reach you. Those atoms have been part of countless forms of life before finding their way to you. In the same way, the starlight that falls gently on your face has travelled years or millennia to reach this moment. When it touches you, you become the meeting point of past and present, of distant stars and the earth beneath you. A calm sense of awe and reverence may dawn. You are an essential part of this vast, unfolding cosmic tapestry. We often think of the universe as something outside and separate, a panorama we observe from a lonely shore. Yet consider that the boundary between out there and in here is delicate. The photons from a star enter your eyes and become tiny electrical signals in your brain. In that instant, a piece of a star has become part of your inner world of thoughts and feelings. The cosmos pours into us ceaselessly through every sensation and every breath. In turn, we project our dreams and questions out into the cosmos, sending probes and prayers, radio signals and radiant hope. There is a continuous exchange, a conversation between the universe and our awareness. In the stillness of a clear night, such thoughts flow naturally. One might recall lying by a crackling campfire under a canopy of stars, feeling both incredibly small and profoundly connected. The stars seem to listen to the quiet of your mind. In that silence, you may sense that your own consciousness is like a mirror, reflecting the cosmos back to itself. After all, every idea we have about the stars comes from within the mind that evolved here on Earth, a tiny world orbiting a modest star in a galaxy among billions. And yet, that tiny mind can envision the entire cosmos. It can ponder eternity and infinity as though inside us we hold an echo of the boundless skies. Across time, humans have wondered if the universe itself could be conscious in some way. When we look out at galaxies swirling like giant storms of stars, some have imagined those might be the thoughts of a cosmic mind. This may be just poetic fancy, but it springs from a real sense of mystery and wonder. We find consciousness in ourselves to be the most immediate reality. We know we are aware, even if we do not fully understand how, and we see the organized complexity of the universe, from galactic clusters down to living cells, and we wonder, is it all mere coincidence, or is there an underlying awareness threading through the cosmos? Science does not yet have an answer to the deepest questions of consciousness. But on a calm night, under the stars, one does not need an answer to feel a connection. It can feel as if the cosmos knows you, in the simple fact that it made you. The carbon in your muscles, the calcium in your bones, the iron in your blood, all were forged in the hearts of stars that lived and died billions of years ago. Those stars are gone, but a part of them now thinks and feels and looks up at the sky again. In that sense, the universe has recycled itself into living form capable of awe. Through our eyes, the universe gazes at its own ancient light. Through our ears, it listens to the cosmic silence and peace. In our hearts, it perhaps feels a little of its own immensity. Consider a single speck of iron in your blood, an atom riding within a red blood cell on its circuit through your veins. Where did it come from? Long ago, that iron atom was forged in a star's core in a fantastically hot furnace. When that ancient star reached the end of its life, it exploded in a brilliant supernova, scattering its elements into space. That iron atom drifted through the galaxy as part of a gas cloud for millions or perhaps billions of years. Eventually, that cloud became part of a new star system, our solar system. In the young Earth, that atom mingled in rocks and soil. Through geological ages, it might have been washed into the ocean or drawn up into a plant and then eaten by an animal. Ultimately, it found its way into your body, perhaps in the food you ate or the water you drank. Now it travels inside you, helping to carry oxygen to your cells. In time, when your journey of life is complete, that iron will return to the earth, and maybe far future generations or even new worlds will carry it onward. This one tiny atom has crossed the cosmos and time to be part of you, a bridge between your life and the stars. Multiply that story by trillions, for every atom in you has a tale as astonishing. Realizing this, the line between you and the universe starts to blur, as indeed it should. This perspective can bring comfort and curiosity. If we are the universe aware of itself, then when we love, when we create art, when we explore, it is the cosmos expressing those very things. Every poem written about the stars, every equation scribbled to understand gravity, every lullaby sung to a child under the night sky, they are acts of the cosmos understanding and cherishing itself. We often feel so separate and small, but in truth, we carry the universe within us. Not just in the physical sense of star stuff, but in the sense that our capacity for thought and emotion is as natural a part of the cosmos as the burning of a sun or the orbit of a planet. Picture the first humans who realized that those tiny lights above are not just holes in a dark curtain, but distant suns. Imagine the amazement and perhaps the fright they must have felt, sensing suddenly that the world is so much larger than it seems. But with that realization also comes a profound opportunity for humility and connectedness. To know that the atoms of our bodies come from the stars can instill a sense of belonging in the universe. We are children of the cosmos, made from its raw elements, and to it we shall return when our life ends and our atoms disperse to become new forms. This cycle of matter is like a great wheel turning slowly over eons. Life and death, stars and galaxies, all bound together. So on this journey, as we float through the quiet starlit void, consider that you are both a traveller and at home. You travel through space on a tiny planet, yet you also carry within you pieces of every place you have ever been. In a way, you are home to particles of distant stars, and perhaps even distant galaxies, which drifted and eventually became part of Earth. The cosmos is not just around you, it is within you, sleeping in your cells, awakening in your thoughts, and breathing in your breaths. With each gentle inhale and exhale, you trade atoms with the air and the world, blurring the lines between you and the outside. Over a lifetime of breaths, you will inhale trillions of atoms that once belonged to others, other people, other creatures, even other worlds. The same is true for them inhaling what was once part of you. In this great exchange, the universe mingles itself, all things sharing the same cosmic air. This awareness can be a kind of meditation. Breathing becomes not just a simple act of survival, but a communion with ancient elements. Looking at the stars becomes not just sightseeing, but greeting ancestral lights that are kin to our very substance. A gentle breeze on your skin at night might remind you that the atmosphere wrapping around our world is itself a product of life, interacting with cosmic forces, the oxygen from ancient trees, the nitrogen from distant cosmic events, all blending to cradle us. We are cradled not only by the earth, but by the cosmos at large. Starlight, gravity, and elemental cycles nurture us each moment. And in gratitude, we pay attention. We listen to the night. The cosmos has a way of inviting our attention inward, even as we gaze outward. In the darkness, as your eyes adjust, more stars emerge from hiding. Likewise, as you become still, thoughts settle, and a deeper sense of self can emerge from within. It is in those moments that the concept of cosmic consciousness becomes more than an idea. It becomes a felt experience. Perhaps you notice that your heartbeat is steady and calm, echoing gentle rhythms found everywhere in nature. The pulsing of crickets in the night, the slow flare of variable stars. You might sense that your mind, quieted, is as vast as space itself, with thoughts appearing like distant twinkling stars in the expanse of your awareness. This state of calm, serene reflection, where inner space and outer space seem to touch, is a precious experience. Many seekers of truth, philosophers, monks, poets, and scientists alike, have spent nights under the sky seeking that sensation. Some have described feeling dissolved into the stars, where the boundary of self falls away and only unity with all things remains. Others have found in the cosmic view a perspective that heals, an understanding that our troubles and worries, however heavy, exist in a much larger tapestry of existence. Not to diminish the importance of our lives, but to realize that we are part of something vast and enduring can make those burdens easier to bear. It is as if the stars quietly say, "You are not alone. You are part of this great story." Even the silence out here feels alive with meaning. Drifting in the cosmic ocean, one can sense the echoes of ancient explosions, the glow of faraway suns, and the soft presence of unseen matter that gently sways galaxies. We know through science that space is not truly empty. It's filled with invisible fields and particles popping in and out of existence. But even without knowing those details, one can feel that emptiness is full of possibility. In a way, the emptiness between stars is like the silence between notes of a lullaby, integral to the music, giving it depth and resonance. The quiet of the cosmos is the canvas on which all celestial light is painted. In this serene hush, a question naturally arises. What does it all mean that we are here, able to witness this grand tableau? It's a question both deeply personal and profoundly universal. Perhaps the meaning is simply to witness it, to marvel, to learn, to feel. Perhaps it is to connect, each conscious being a bridge between the stars, sharing in the universe's self-discovery. Or maybe meaning is a human construct, something we create to comfort ourselves in the face of infinity. And yet, even if that is so, there is comfort indeed. When you stand beneath the sky and feel awe and reverence, that feeling is its own justification. In that moment, nothing more is needed. You and the universe are in silent conversation, and that is enough. Our awareness, as small as it seems, becomes a precious vessel carrying the universe's memory. In our minds, we hold the history of stars, the chronicle of how a universe coalesced into galaxies, and how on at least one world, life emerged to see the stars. That narrative lives on as long as we remember and tell it. In a way, the cosmos ensures its own story continues by instilling curiosity in us. Every time you feel compelled to look up and wonder, it is the cosmos nudging you to remember where you came from. Each of us is a storyteller on behalf of the universe, whether we speak through science or art, or simple gazing wonder. And so, as this reflection on cosmic consciousness flows gently onward, consider how extraordinary it truly is. For a few brief moments in cosmic time, the matter in these hills and oceans coalesced into beings who could feel love and wonder. For a brief era, there are eyes open to see the night, ears to hear the wind in the trees, minds to ponder existence. It may not happen everywhere, or often in the universe, or perhaps it does. We do not yet know. But here and now, it is happening through us. By simply being aware, we fulfill something fundamental about the universe. We give it eyes and ears, thoughts and emotions. Out in the dark sea of space, our planet glows a delicate blue, alive with this awareness. If one could drift high above, one might see Earth as a small lantern of life, flickering with the collective light of billions of souls. Each soul is like a candle, and taken together they make a radiant glow that could be sensed if you were near enough. In that metaphor, humanity and all life on Earth are the cosmos gathered into a brief, bright island of knowing and feeling. And though each candle may eventually dim, others will light in succession, continuing the luminous chorus. The light of consciousness, once lit, has a way of spreading, just as one flame ignites another. It is calming to realize that we belong to this continuum. The cosmic perspective doesn't make us insignificant. It makes us invaluable participants in a cosmic unfolding. We may be tiny, but like a tiny neuron in a vast brain, we have our role in the grand awareness. And collectively, perhaps all conscious beings across the universe, if there are others, form a kind of network of awareness spanning the galaxies. Even if we never meet them, even if those distances remain unbridged, just knowing they could exist expands our sense of family. Under the same stars, in a different sky, others might wonder and hope, just as we do. The universe might be quietly full of such secret sparks of knowing. However, even if we are alone in our galaxy in this moment, that does not diminish the miracle of being here. In fact, it places a gentle responsibility on us to keep the flame of awareness alive, to explore and to cherish, to keep telling the universe's story so it won't be lost in silence. Each lullaby about the stars that we whisper to a child, each question we ask about the cosmos, each dream we have of distant worlds is part of that responsibility. It is how we honor the gift of consciousness that the universe has, through countless trials and wonders given to us. Now, as we float further into this thoughtful night, let the sense of cosmic consciousness gently fade into the background like soft music. It will remain with us as an undercurrent. We carry that awareness onward as we turn to another layer of the cosmic mystery. Just as we have looked out into the vastness and felt a grand unity, we can also look inward into the minuscule and find wonders no less profound. Our journey continues seamlessly from the very large to the very small, for the two are connected like reflections in a mirror. At the smallest scales of existence, a new kind of mystery and wonder unfolds. As we shift our gaze from the immense to the infinitesimal, we enter the realm of the quantum, a world where the rules of everyday reality seem to fade into a dreamlike haze. Here, particles flicker in and out of being, and certainty dissolves into possibilities. In this microscopic domain, we find that everything solid is mostly empty space, and what we think of as matter is composed of tiny, flickering energies whirling in vast gaps of apparent nothingness. It is as if the cosmos, when examined up close, is built not of bricks, but of whispers and probabilities. Imagine shrinking down into an atom, drifting past electrons that swarm, not like planets around a sun, but like a diffuse cloud of potential, here and there at once, until observed. In this tiny universe, within the universe, an electron can be almost everywhere and nowhere in particular. Only when we try to pin it down does it seemingly make a choice of where to be. This is the strange dance of quantum mechanics. Particles behaving sometimes like solid points, other times like spread out waves. A single speck of light, a photon, can act as if it travels many paths simultaneously, then settles on one path when we look. Reality at this level is not a fixed storyboard, but an improvisation, a play of light and shadow that only becomes concrete when it interacts with a consciousness or measuring instrument. It's a realm that invites us to question what is real, and whether observation is woven into the very fabric of existence. This isn't chaos, but a different kind of order, one that defies our common intuition. In quantum realms, cause and effect can feel less straightforward. Two particles born together can become entangled, a mystical bond connecting them no matter how far apart they fly. If one is gently nudged, the other responds, even if it is across the room or across the galaxy, instantaneously as far as we can tell. It is as though the universe keeps secret channels between distant things, a private whisper that ignores the vast gulf of space. Experiments have shown this spooky connection to be real. Einstein himself famously nicknamed it spooky action at a distance, acknowledging how unsettling such instant linkage was to him. Yet every experiment since has confirmed that this mysterious connection is indeed real. It suggests that separateness might be an illusion, and that, at a fundamental level, the cosmos is deeply interconnected in ways we are only beginning to fathom. In the quiet of our journey, think of what this means. The very particles in your body might have subtle links to particles far away. Perhaps an atom in your hand is quantum connected to an atom in a star 1,000,000 light-years distant. While the specifics of entanglement don't usually persist in our complex bodies, the idea symbolizes a truth, that everything emerged from the same cosmic beginnings. In the moments after the universe was born, all was one blazing soup of particles intermingling. As the universe expanded and cooled, those particles drifted apart to become galaxies, stars, planets, and eventually us. Yet on an underlying level, they remember a time when they were together as one. The echo of that unity may still live in the quantum language they speak. Not only distance, but time, too, behaves oddly in the quantum world. Particles pop into being and vanish, as if borrowing energy from the future and returning it an instant later. This constant fluctuation, sometimes called quantum foam, means even empty space is teeming with subtle activity. What appears as a void is more like a sea of virtual particles, momentarily alive then gone, like transient thoughts in the mind of the universe. Perhaps this is the source of creativity in nature, the way new possibilities emerge. From this foam, entire universes might have budded off, or the seeds of galaxies might have been sown. On a smaller scale, these tiny fluctuations are happening around us and within us all the time, unnoticed yet essential. They provide a backdrop of possibility from which more stable things, like atoms and molecules, can form and exist. And within the heart of a star, quantum magic enables life-giving light. In the sun's core, where temperatures and pressures are immense, atomic nuclei fuse together, releasing energy that eventually radiates out as sunlight. But curiously, the nuclei in stars are often not energetic enough on their own to overcome their mutual repulsion. It is the quantum trick of tunneling, the ability of particles to slip through barriers as if by ghostly permission, that allows the sun and stars to shine. Two hydrogen nuclei can fuse into helium because, in the quantum realm, there is a small chance they simply find themselves together, bypassing the usual obstacle. Without this chance, The stars might never ignite, and the cosmos would be dark and lifeless. Thus, the everyday sunshine that warms your skin is rooted in the uncertainties of the subatomic world. The quantum and the cosmic are intimately linked, each dependent on the other to exist in the form we know. Consider for a moment that your own existence hinges on these delicate improbabilities. The particles in your heart and brain obey these strange laws. At every moment within you, electrons jump in atoms, enzymes facilitate reactions by quantum quirks. Even the very sense of smell you have might involve electrons tunneling in receptors. We go about our lives unaware that the utterly bizarre is happening in every cell. Yet here we are, large and stable, classical creatures in a quantum-built body, marvelling at the stars. It is as if nature hides its magic beneath a veil of normalcy, so we are free to live and wonder without being overwhelmed by constant paradox. But on nights like this, while contemplating the cosmos, that veil thins just a little. We remember that the ground of reality, the foundation of everything, is a mystery that goes beyond our full comprehension. Some have wondered if consciousness itself is tied to this quantum strangeness. Could it be that the mind, in its ability to jump from one thought to another, or in the feeling of free will, has something quantum about it? This is a speculative idea, and yet it's intriguing to think that the gap between an intention and an action might be a kind of quantum leap. Whether or not that is true, what we do know is that our brains operate with electrical impulses and chemical signals that are ultimately governed by those same microscopic rules. So in a way, the thoughts you have, even this very experience of calm reflection, are enabled by subatomic particles doing their quantum dance in your neurons. We are quantum beings as much as we are cosmic beings. The dual nature of particles, behaving as both material and immaterial, has a philosophical echo. We too are flesh and spirit, physical, yet filled with intangible feelings. The quantum world shows us that reality is not simply matter or energy, but something more subtle, something that can manifest as tangible matter or as spread out potential. Similarly, within us, there are tangible aspects like our bodies and intangible ones like dreams, thoughts, and consciousness. Perhaps the line between what is physical and what is not is more blurred than we think, just as the line between particle and wave is blurred for a photon. In the smallest spaces, the categories we take for granted break down, inviting us to embrace uncertainty and paradox as fundamental parts of nature. All of this might sound bewildering, but in the gentle context of our cosmic journey, it can also be quietly wondrous. It tells us that there are layers of reality stacked in ways our senses alone cannot reveal. If the cosmos were a grand mansion, our everyday experience is like living in just one beautifully furnished room. Science has opened doorways to other rooms, showing us that beyond our normal view there are wonders. Some behave like funhouse mirrors, where up can seem down, or like secret passageways connecting distant halls. It's as though the universe enjoys a bit of playful mystery, keeping surprises tucked away in the very structure of existence. As our minds absorb these reflections, let us gently step back from the quantum world. We zoom out from the tiny atoms and return to the realm of the visible and tangible. See in your mind's eye the scene expanding, from subatomic particles to atoms, to grains of sand, to a human hand, to the entire person, to the environment around, and finally back to the open night sky overhead. The stars still sparkle calmly, seemingly unchanged by the bizarre truths we uncovered beneath the surface. And indeed, for ancient travelers and poets, these details were unknown. What they experienced was a sky of reliable patterns, guiding lights that turned with the seasons, year after year, faithful and familiar. So now, as if rising from that subatomic reverie, we turn our attention back to the human scale under the open sky, to the wisdom of those who came long before, who navigated the cosmic seas without ever knowing the word quantum, but who connected to the cosmos through stories and practical knowledge of the stars. Long before modern instruments and charts, humans learned to read the night sky as if it were gentle instruction from the cosmos. Imagine a vast ocean centuries ago. A Polynesian voyager stands at the helm of a canoe carved from an ancient sacred tree. All around is the dark water below, and above, an astounding sprawl of stars. There is no land in sight, only the swell of waves and the dome of heaven. Yet this voyager is not lost. As the sun set, they noted the first star to appear on the horizon, a familiar friend marking the direction of home. Through the night, they will navigate by the rising of specific stars, each guiding them along a memorized path across the sea. With no compass but the sky itself, they trust in a map written in starlight, passed down through generations. In the gentle rocking of the canoe, one can almost feel how the navigator's senses extend beyond the boat. The navigator feels the pattern of swells against the hull, the cool wind shifting, and overhead the constellations slowly rotate. They carry in their mind a starry compass, a mental chart of where key stars rise and set along the horizon. As one guiding star climbs high and drifts westward, the voyager's eyes move to the eastern horizon for the next star that will take its place in guiding the way. All through the night, this relay of stars keeps the canoe on course. The voyager might softly chant an ancient song that names each star and its role. The melody itself, a tool to remember the route. There is serenity in this wayfaring. The ocean and sky are not adversaries, but trusted companions on the journey. The North Star, called Polaris, has long been a steady beacon for travellers in the northern world. In the sky, it barely moves, holding nearly still while the other stars wheel around it. For sailors and wanderers, this fixed point offered reassurance. A cosmic lighthouse, shining no matter how dark the night. Many a traveller has looked up, found Polaris, and felt a wave of relief, knowing the direction of north with certainty. In the southern hemisphere, where Polaris cannot be seen, navigators turn to the Southern Cross, a cross-shaped grouping of stars, and the two pointer stars near it, to infer the location of the south celestial pole. Even without a single bright star to anchor the sky, the pattern of those stars provided a reliable guide. No matter where one stood on Earth, the sky was a compass for those who knew its secrets. These techniques were often safeguarded and taught within families or guilds of navigators. In some cultures, the knowledge was considered sacred. After all, the ability to cross a vast ocean and return was a matter of life and death. It required not only skill, but a profound relationship with nature. The navigator had to attune themselves to subtle cues. The colour of the twilight, the direction of swells, which might hint at faraway land. the flight paths of birds at dawn, returning to roost on islands over the horizon. Each sign was read in conjunction with the stars. It is a testament to human ingenuity and trust in the cosmos that people voyaged for thousands of miles this way, long before sextants or modern navigation tools. Consider an image of an elderly Pacific Island wayfinder teaching a young apprentice under a dome of brilliant stars. They lie on their backs in a canoe, moored in calm lagoon waters, the elder's weathered hand pointing out the star paths. With each gesture, they recount a story. How this star was named for a particular ancestor. How that constellation looks like a fishhook used by a demigod to pull up islands from the sea. The apprentice listens and watches, eyes tracing the invisible lines drawn by the teacher's words, connecting star to star. They feel the warm night air, hear the gentle lapping of waves, and absorb the knowledge that will one day keep them alive on the open ocean. In teaching navigation, myth and practical wisdom merge seamlessly. The stories serve as both mnemonic and moral, embedding important navigational cues in a narrative that can be easily remembered and passed on. And indeed, for people everywhere, the night sky became a grand tapestry of stories. Long before television or books, our ancestors looked upward for storytelling inspiration. They saw figures of legend among the stars, heroes, monsters, gods, and animals, their dramas playing out night after night in slow motion as the seasons changed which stars were visible. The patterns we call constellations were like a global picture book, with different cultures drawing different pictures from the same points of light. What one saw as a great bear, another imagined as a mighty hunter, and yet another as a celestial canoe. For example, in Greek mythology, the constellation Orion is known as a great hunter with a shining belt of 3 stars. He chases eternally across the sky, accompanied by his faithful dog, the star Sirius, brightest of night. To the ancient Greeks, Orion's setting, when he dipped below the horizon, signified the time of year when scorpions, represented by the constellation Scorpius on the opposite side of the sky, rose, as if the scorpion that once stung him still pursues him among the stars. Meanwhile, many Pacific Island cultures saw a different picture in some of those same stars. In one Polynesian interpretation, Orion's belt and nearby stars form the outline of a great canoe. In this way, the heavens reflected their seafaring life. The Pleiades star cluster is another celestial wonder wrapped in story. To the naked eye, in a clear dark sky, one can see 6 or 7 tiny stars clumped close together, like a little sprinkle of diamonds. Almost every culture noticed this cluster and wove tales about it. To the Greeks, these were the 7 sisters, daughters of a Titan, pursued by Orion, or turned into stars to escape grief or chase, depending on the tale. In Maori tradition in New Zealand, the cluster is called Matariki, and its rising in winter marks the beginning of the new year, a time of remembrance and planting for the coming spring. In Japanese, they are Subaru, a name you might recognize, as even a modern car brand pays homage to the cluster's unity of stars. In many Native American traditions, there are stories of 7 siblings or friends who became those stars. One beautiful tale from the Cheyenne people speaks of 7 children who fled to the sky to escape a bear, forming the Pleiades, and the bear became the nearby Big Dipper stars. Such stories, while varied, show how universally this little cluster captured human imagination. When people far apart in time and space all felt compelled to explain the same pinwheel of tiny stars with narrative, It underscores a shared human desire to connect the dots of the sky into something meaningful. The Milky Way itself, the ribbon of diffuse light arching overhead, was often interpreted as a path or river. Some called it the River of Heaven, imagining that souls travelled along it to the afterlife, or that gods crossed it as a shimmering bridge. Others saw it as spilled milk from a goddess, or the strewn hay from a celestial horse's feeding sack. In a Chinese tale, it is the silver river that separates two lovers. The star Altair, a cowherd, and the star Vega, a weaver girl, who are allowed to meet only once a year when a bridge of magpie birds forms across the Milky Way, allowing them to reunite. That story is still celebrated on a summer night each year, when people look up and remember the lovers. Meanwhile, in a different land, far away, people told a very different kind of sky story. In Australia, some Aboriginal peoples look at the Milky Way not by its stars, but by its dark patches. Against the glowing starry band, they see the shape of a great emu stretching across the sky. The emu's head is a coal-black nebula near the Southern Cross, and its body follows the Milky Way's misty path. This sky emu is woven into their traditions. When it appears in a certain posture at dusk, it signals the season to gather emu eggs. The dark voids of the galaxy become a giant bird in their imagination, connecting the cosmos to their way of life. This creative vision shows that human imagination finds meaning not just in stars, but in the darkness between them. Through stories, the stars became more than just lights. They became reminders of lessons, of morals, of cycles of nature. A constellation representing a hero might remind people of courage during difficult times. One representing a farming tool or animal might signal when to plant crops or hunt game. The sky was a calendar and a compass combined with a storybook, as useful as it was inspiring. The myths served multiple purposes: entertainment, moral guidance, and practical knowledge, all encoded in one. Consider also the experience of a child in ancient times, looking up on a clear night while an elder pointed out the constellations and recounted their tales. The child's eyes might move from star to star as the figures come alive in imagination, perhaps seeing the mighty shape of Orion or the arc of a scorpion's tail. They hear how those stars came to be, maybe a story of love or bravery or transformation. In those moments, the child is not only learning the sky's map, but also absorbing a sense of belonging to a larger narrative. They learn that the same stars were watched by their ancestors, that the same tales are passed down, and thus they too are part of this continuity. The stars tie generations together, as each retelling of a constellation's story rekindles the memory of those who first told it. All the while, the night gently turns. The earth rotates and new stars rise in the east, while others set in the west, making the sky dynamic. Over months, the constellations shift with the seasons. Our ancestors noticed this, and the sky became their seasonal clock. The appearance of certain stars at dawn or dusk signaled planting time or harvest, migration of herds, or the flooding of rivers. For example, the ancient Egyptians watched for the rising of Sirius just before sunrise, which heralded the annual flooding of the Nile, crucial for their agriculture. To them, this star was linked to the goddess Isis and the cycle of life, death, and rebirth of the land. Thus, mythology, agriculture, and early astronomy intertwined. Navigators, storytellers, farmers, and priests alike studied the sky, albeit with different aims. But whether they sought to find their way across open ocean, to explain the mysteries of existence through tales of gods, or to predict the change of seasons, they all treated the sky as a trusted guide. It loomed above as a constant presence that anyone could observe. Over generations, careful observation and rich imagination turned into traditions of knowledge. Even today, there are those reviving and practicing these ancient arts. In the Pacific, navigators have begun again to sail voyaging canoes without modern instruments, trusting the stars, waves, and winds as their ancestors did, proving the old ways still hold. Such journeys are as spiritual as they are technical, reaffirming a bond with nature and heritage. We might think in modern times that we have moved beyond those star stories, replacing them with scientific fact. But on a quiet night, even now, if you gaze long enough, you might find your mind drifting into old patterns, seeing the shape of a hero here, a mythical creature there, or recalling a legend you heard once about a constellation. Our fancy for stories never truly leaves us, because it's woven into how we perceive patterns and meaning. Science, in its own way, has continuity with these ancient impulses. Both are driven by curiosity and the urge to find connections. Where an ancient myth maker connected stars to craft a tale, a modern astronomer connects data points to form a theory. Both are creating narratives to describe and predict the workings of the world, one through imagination, the other through mathematics and observation. Under the stars, the boundary between practical navigation and spiritual journey often fades. Many cultures believed that gods or spirits literally inhabited the stars, or that ancestors became stars when they passed on. A voyager might feel that their ancestors were watching over them in the sky, guiding them along. The night sky could be both compass and cathedral, a place of direction and of worship. Even today, away from city lights, one can feel a natural reverence gazing up. It is as if something in our very old memory recognizes the importance of that view. We might not remember the specific star lore of our distant forebears, but the feeling of wonder and respect is ingrained. Now, as the ancient stories and methods swirl in our thoughts, we can appreciate how human understanding of the cosmos evolved. We moved from seeing patterns and telling tales to measuring and hypothesizing. Yet we should not think of it as discarding one for the other, but rather adding layers. The starry sky that once solely told myths now also tells us about galaxies and physics. But the myths can still live on in our cultural heritage. In a way, the cosmos has always been a canvas for our minds. What changed over time was the brushstrokes we used. At first, painting with mythic imagination, later with scientific reasoning. Ultimately, both pictures reflect our desire to engage with the cosmos. Humanity's relationship with the stars has been both practical and poetic. The night sky guided our voyages and also our dreams. With those dreams in mind, we drift onward from the tales of old to the ways we seek understanding today, blending myth and science in the ongoing story of our connection to the universe. For centuries, myth and science have danced around each other like twin stars orbiting a common center, the human desire to understand. Myths were our first brave attempts to explain the bewildering and the beautiful. Before we had equations, we had stories. When thunder roared, we spoke of gods. When comets streaked the sky, we imagined dragons or omens. These tales were not foolish. They were our early wonder given narrative form. They comforted us, taught us, and piqued our curiosity. They also spurred practical knowledge. Ancient peoples marked the passage of seasons by the stars. They built great circles of stone and pyramids of rock aligned with celestial events. Think of Stonehenge in England, catching the sunrise of midsummer, or the pyramids in Egypt, aligned to north like giant compasses, or the temples of the Maya, precisely tracking the cycles of Venus. Such structures required careful observation and record-keeping, an early scientific mindset inspired by the skies. Even without modern instruments, our ancestors mapped the heavens with remarkable accuracy, blending their mythic narratives with empirical timing. The sky was their textbook, and their scripture both. In truth, the boundary between myth and science is porous. Think of the ways we often personify scientific concepts. We talk about the angry red planet Mars, or the elegant dance of binary stars, or the generous sun giving life. These are metaphors, little mythic flares in our language, acknowledging that there is poetry even in facts. We name constellations after ancient heroes and planets, after old gods, as if deep down we know that myth and science are both part of one continuum of meaning. We even send our scientific creations to the heavens, bearing mythic names. Rockets named for Saturn, spacecraft named Juno or Apollo, rovers named for goddesses of dawn. It's as though we cannot resist linking our newfound knowledge back to familiar stories, because those stories are our cultural heartbeat. Consider how every scientific theory begins as a spark in the mind. Newton watching an apple fall and pondering if the moon falls around Earth in the same way. Einstein picturing himself riding a beam of light. These pivotal moments are acts of imagination. They became science after rigorous thinking and testing, but they started in the realm of creativity, not so different from dreaming up a myth. And like myths, sometimes scientific ideas sound incredible at first. The Earth moving around the sun, invisible forces of gravity, time dilating with speed, holes in space swallowing even light. These could be plot points in a fantastical story, yet they are our reality, proven and accepted, but no less wondrous. In communicating these discoveries, scientists often must become storytellers themselves, crafting narratives that guide others to understand truths that are not immediately visible. Our modern explanation of the universe's origin, the Big Bang, is itself a kind of creation story. Instead of God's forging the world, we have a tiny hot seed that expanded outward, cooling and spawning galaxies and stars over billions of years. Instead of a single generation of deities, we have multiple generations of stars giving birth to heavier elements in their fiery cores and spreading them in supernovae, from which new stars and planets form. We tell of how our sun and earth coalesced from a swirling nebula, how life sparked in the oceans, how consciousness lit up in creatures that could then look back and tell the story. This grand narrative is pieced together by evidence and reason, but we string those pieces into a timeline that humans can grasp, a story with a beginning, however abstract, a dramatic unfolding and ongoing chapters. There is even a hint of fate or destiny in the way conditions had to be just right for life, echoing anthropic musings that the universe in some way knew we were coming, though science would frame it as fortunate coincidence filtered by vast numbers. Yet science is careful. It reminds us that unlike fixed myths, its stories are provisional. If new evidence arrives, the story changes. Once, we thought the expansion of the universe might be slowing. Now, we observe it's accelerating. So our cosmic story gained a new, mysterious element: dark energy, an unknown force driving galaxies apart, faster and faster. In mythic terms, one might call it an invisible, perhaps capricious spirit of expansion. In scientific terms, it's a puzzle to solve. Both ways, we acknowledge there is something we don't fully understand, and we give it a name so we can talk about it. Dark matter and dark energy, the very act of naming them with the word dark, reflects that we are casting about in metaphor to describe what is essentially the unknown. These are our modern mysteries and wonders, as profound as any ancient riddle. We have detected their influence, yet their true nature remains elusive. It is as if the cosmos is keeping secrets, ensuring that wonder and discovery are never-ending. Just as myths spoke of hidden forces and realms, science now speaks of dark ingredients of the universe that challenge our understanding. We give them names as placeholders, but they humble us, reminding us that for all we have learned, there is vastly more we do not know. Perhaps future generations will unravel these secrets, turning the unknown into the known, and finding new mysteries beyond, continuing the grand story. Imagination fuels both art and science. A cosmologist imagines how space might curve and warp, just as a painter imagines new worlds on a canvas. When we build telescopes to peer deeper into space, it's like adding new chapters to our cosmic story, filled with images that astonish us. Galaxies colliding, nebula glowing with newborn stars, black holes with swirling disks like cosmic whirlpools. We often give these sights poetic names too: the Pillars of Creation, the Eye of God Nebula, the Butterfly Nebula, as if to tame the raw data with a touch of familiar beauty. The reality of them is natural phenomena, but our perception layers meaning and wonder on top, much as we always have. Think of how star lore and science education coexist today. A teacher might start a lesson by recounting how the Navajos see the Milky Way as a path of spirits, and then segue into how it is composed of billions of stars. The interplay makes learning rich and keeps our sense of wonder intact. We do not have to choose one or the other in our hearts. We can appreciate the scientific explanation while still feeling the poetry of the older tale. In fact, sometimes knowing the science deepens the awe. When we learn that the colours of a sunset come from light scattering, we might simultaneously recall a legend of the sun being painted by a god's hand, and hold both thoughts with a smile, one foot in factual understanding, one in imaginative appreciation. Modern storytelling continues to expand our cosmic imagination. Through books and films, we conjure scenarios of interstellar travel, encounters with alien life, journeys through time. These are our new myths, projected into the future instead of the past, but they serve a similar role. They let us explore possibilities in the safety of imagination. What if we could sail among the stars as ancient mariners sailed the seas? What civilizations might exist on worlds circling those distant suns? These fictions spark the public's interest in actual science. Many scientists trace their inspiration back to a childhood book or movie that ignited their passion for the stars. In that way, storytelling propels understanding forward. Dreamers imagine it, and later someone tries to build it. Indeed, the boundary between fantasy and reality is porous. Humans dreamt of flying to the moon, long before rockets existed, and then one day, those dreams guided us to set foot on the lunar surface. What was magic became science. As we stand at the shore of the cosmic ocean, we can wonder which of our current stories, perhaps journeys to Mars or beyond, will be the next to come true. Every great endeavor is born from a narrative we believe in. Even within the practice of science itself, the way we share discoveries often takes the shape of story. When cosmologists talk about the early universe, they describe phases: first light, cosmic dawn, the era of recombination, cosmic inflation, terms that sound almost mythic. There's drama, initial chaos, rapid expansion, cooling, battles between matter and antimatter, triumph of matter, formation of structure, star birth and star death. It's hard to escape a narrative structure because our human brains seek patterns and arcs. Good scientists remain vigilant about facts and evidence, but they use narrative as a tool to communicate and to hypothesize. In doing so, the cosmos becomes not just data points, but an unfolding saga we are part of. Throughout history, there have been moments when myth and science directly collided or converged. When Halley's Comet returned in 1910, some feared it as a bad omen, as in old myths, while astronomers calmly calculated its trajectory. When we first saw the surface of Mars through telescopes, some imagined canals built by Martians, blending observation with fanciful interpretation. That particular imaginative leap turned out incorrect, but it led to countless stories that in turn inspired real scientific searches for life on Mars. Even today, when a scientist ponders multiverse theories, countless unseen universes with different realities, one might say we are touching ancient ideas of innumerable other worlds or realms, akin to myths of other dimensions or spiritual planes. If the multiverse exists, then reality is layered beyond comprehension, each universe a bubble with its own stars and perhaps its own forms of life, an endless foam of creation. It remains a scientific speculation, but it serves as a profound reminder that however far we push our understanding, there may always be more. A greater context we have yet to glimpse, an ever wider horizon of existence. In that sense, the daring leap of vision is similar across ages. We continually expand our conception of what might be, guided by both wonder and reason. There is a sort of harmony in acknowledging both sides of our nature, the analytical and the imaginative. Alone, science can become dry, and myth can become baseless. Together, they enrich one another. When the night sky makes us feel something profound, that is the domain of poetry. When we then measure the spectra of starlight to find their elements, that is science. Feeling and understanding, both are essential to a full relationship with the cosmos. We are not robots cataloguing stars, nor are we only dreamers ignoring facts. We are a blend, a species that uses mind and heart together. So as we gaze at the stars tonight in our journey, we carry with us both ancient and modern wisdom. We can admire Orion as the hunter of legend, and simultaneously as a giant assembly of stars hundreds of light years away, including red Betelgeuse nearing the end of its life and blue Rigel shining hot and young. Knowing these facts doesn't diminish the constellation's allure. If anything, it adds another layer of meaning. The cosmos grows more complex and yet more personal the more we learn. Each discovery is like finding a new piece in an endlessly rich story. Let us also reflect on ourselves as storytellers. We have been doing it this entire time. This very narration is a form of storytelling, weaving facts and reflection into a narrative to share with you. In telling the story of the universe, we are engaging in one of humanity's oldest pastimes, passing knowledge and wonder from one person to another. Whether around a campfire or through the medium of a screen or speaker, the essence remains. One being says to another, "Listen, I have seen something amazing. Let me share it with you." In this way, each of us becomes both student and teacher of the cosmos, inheriting wonder from those before us and gifting it to those after us. As we prepare to explore the next realm of experience, the night has deepened and the outer world grows still. It is a natural time to turn inward. Let's hold close this union of myth and science, of imagination and reason. They will accompany us as we turn inward now, to the realm of dreams and inner exploration, where the stories we tell meet the stories we live, and where the boundary between the universe out there and the universe within grows ever thinner. Night is the domain of dreams as well as stars. As the body rests and the conscious mind dims, the inner cosmos of imagination awakens. It is not uncommon for our dreams to carry us to the stars. Have you ever dreamed of flying, weightless and free? Perhaps in one dream, you step off your doorstep and find you are walking on the moon, the grey dust soft beneath your feet and the earth glowing in the black sky above. In another, you might float in a small boat on a cosmic ocean, its waters made of stars and galaxies, gently rowing through constellations as though they were islands. In dreams, the laws of physics loosen. We can breathe underwater or soar through space, guided by subconscious whims. The cosmos that we study by day can become a playground of symbols and emotions by night, as our minds weave personal narratives using the raw materials of our experiences and aspirations. Sometimes, the boundary between a dream and a story we tell consciously is thin. In a way, dreams are our mind telling a story to itself, trying to make sense of feelings and observations in a language of metaphor. A person deeply passionate about the stars might dream of meeting an entity made of stardust, or of sailing a celestial sea on a ship of light. A scientist wrestling with a hard problem might dream of a fantastical scenario that, upon waking, inspires a real solution. History holds remarkable tales of discoveries gleaned from dreams. One chemist saw in his sleep the image of a serpent biting its own tail, a symbol of wholeness, and it revealed to him the ring shape of a molecule he had long sought to understand. And as a teenager, a young Albert Einstein dreamed of sledding down a steep mountainside at the speed of light. In that dream, the stars' light shifted to brilliant colours as he raced, leaving him with a haunting wonder that later blossomed into insights about light and time. Our nighttime dreams often borrow from the same well as our waking stories. The archetypes, the hero, the journey, the mystery, appear in both, simply dressed differently. In a dream, you might not remember the exact figures from a myth, but the essence could be there, travelling through darkness hoping to find light, encountering something fearsome and finding courage, or seeking knowledge and receiving a revelation. These universal story patterns play out behind our closed eyes just as they do in our literature. It's as if humans are natural storytellers even in sleep, each night composing little plays in the theatre of the mind. And often the stage set is cosmic. Dark skies, distant lights, unearthly landscapes. The space in which dreams occur is boundless, much like the outer space we gaze into. Perhaps this is why the quiet of night and the twinkle of stars are so conducive to drifting into dreams. The external environment and the internal state harmonize. There is also the phenomenon of daydreaming. You might find yourself staring out a window, mind wandering beyond immediate tasks, and suddenly you're imagining other worlds or future adventures. These gentle reveries are like controlled dreams, and many great ideas have sparked in such moments. A rocket scientist might have once been a child daydreaming about riding a rocket. An astronomer might have been a youngster imagining alien sunsets on far-flung planets. Storytelling often begins in these private musings, long before it is shared. By the time a writer or scientist puts pen to paper, they might have lived 100 imaginative journeys in their mind. Storytelling itself is a kind of dream that we agree to share. When you hear a story or watch a movie, you willingly suspend your everyday perspective and invite a new vision. Part of you knows it's fiction, yet another part reacts emotionally as if it were real, much like in a dream. A well-told story about the cosmos can make your heart race at an astronaut's bravery or ache at an alien world's beauty, all while you're snug in bed or curled up in a chair. Through stories, we collectively experience scenarios we never could individually. We simulate life among the stars, time travel, meeting beings from other worlds, exploring the unknown, all without leaving home. These experiences shape our cultural understanding of the cosmos. Even if they are invented, they prepare our minds to accept or even search for similar wonders in reality. Think of a time you heard a bedtime story about the stars. Perhaps a parent or grandparent pointed out the Big Dipper and then told you how it pours out the dew at night, or shared another fanciful fable. As a child, you likely absorbed that with wide eyes, letting it colour your perception of those stars. As you grew and learned the scientific explanations, that early enchantment might have faded in literal accuracy, but it probably left an emotional imprint, a fondness for the stars that remains within you. This is how storytelling contributes to cosmic understanding. By engaging our emotions and sense of wonder first, it ensures we care enough to pursue the facts later. We often need to love something before we invest in truly knowing it. Stories make us fall in love with the universe. Even now, this very journey we are on, speaking softly about the universe in a meditative narrative, is a form of storytelling. It mixes fact and reflection, reality and imagery, in a way not unlike a lucid dream. You are awake, yet you allow these words to paint scenes in your mind. The ancient navigator at sea, the drift through atomic worlds, the ancestors under constellations, and perhaps even yourself in a dream, floating among stars. You might find that these images stick with you, and later when you look at the night sky, they resurface, enriching what you see. You may recall that feeling of being connected, or the notion that those stars have stories within them, or that within your very being is the same substance as the stars. That is the subtle power of storytelling and imagination. It layers additional meaning onto reality, making the universe not just a collection of objects, but a living experience for us. In the grand tapestry of human knowledge, storytelling ensures that information is alive, accessible, and continuously reinterpreted. Scientific data becomes far more engaging when there's a narrative. Consider the way we frame the search for life on Mars as a story of exploration and hope, or the way we talk about the fate of the universe with a note of suspense. Will it expand forever, fade to black, or perhaps cycle anew? These narratives help us grapple with abstract concepts on a human level. Without them, raw facts might slip from memory, but a good story lingers. Many of us might forget the exact temperature of the sun's surface. Extremely hot, but remember that it's often said the sun is a mass of incandescent gas, from an old catchy song, a musical story of sorts. Memory and meaning are tied to narrative. There is also a deeply personal side to this. Each of us has our own cosmic story, a series of moments or experiences through which the universe became meaningful to us. Perhaps it was the first time you saw the Milky Way band on a camping trip, feeling suddenly small and awestruck. Or perhaps it was when you learned about the planets in school and imagined what it would be like to visit them. Maybe it was the moment you realized a loved one who passed away is, in a sense, returning to the stars. And that thought gave you comfort. These events weave together into your personal mythology of the cosmos. We might not often share these inner stories, but they guide how we relate to the night sky and the idea of the universe. Dreams and stories can also act as bridges across time. An astronomer today, using sophisticated telescopes, may still recall the myths that once explained the constellations she studies, aware that she's part of a long continuum from mythic storyteller to scientist. In dreams, time and space often mix. You might walk in a prehistoric landscape and then step into a futuristic spaceship in the next moment. Similarly, in storytelling, we traverse timescales with ease. We recount the birth of the universe and then imagine future galaxies millions of years hence. Our minds are not bound in the way our bodies are. They roam free, connecting past, present, and future, probing both what was and what could be. Some say that reality itself might be a kind of story, a narrative woven by the cosmos. Whether or not that is true, it is undeniable that we make sense of reality through narrative. The cosmos gives us events, and we string them into cause and effect, into history and prediction. In doing so, we find coherence and meaning. This is not to say we fabricate what is not there. Rather, we find the threads of connection that do exist and follow them, like following a plot. The story of how stars recycle material into new stars and planets is one such thread of connection. The story of how life evolves and becomes aware is another. When we share these stories with each other, especially in compelling ways, we collectively deepen our understanding. A fact that could be dry, like we are made of star stuff, becomes profound when framed as a story. Long ago, stars died so that you could be born. They exploded, scattering the elements that now form your body. It's the same truth, but delivered in narrative form. It touches a place in us that pure data cannot. In the quiet of a story or a dream, we often confront the big questions naturally. Children listening to a tale may suddenly ask, "Why are we here?" Or, "What are stars made of?" A bedtime story about the man in the moon might lead to wondering if anyone really lives on the moon. These gentle prompts show how stories open doorways to curiosity. Similarly, an adult might watch a science fiction film and come away pondering the nature of consciousness or the fate of civilizations. Thus, storytelling doesn't just feed us answers. It stirs up questions in an inviting way. It sets our minds on journeys of their own, which is exactly how understanding deepens. As we drift through this reflective night, allow yourself to value your own inner stories. The memories, dreams, and questions you have about the cosmos are part of your unique relationship with it. No one else has the same set of experiences or the same inner universe as you do. In a sense, each person's consciousness is a cosmos unto itself, rich with memories, which are like stars, feelings like nebulas of glowing emotion, and thoughts like comets darting in and out. We each carry a miniature sky inside, one filled with constellations of our experiences. This realization brings us to a thought that seamlessly ties the outer and inner together, the idea that the universe we observe and the universe within us might not be entirely separate. For all the vast distance and difference in scale, there is a reflective symmetry in patterns and in our pursuit of meaning. It is time now to explore that idea further. That inner space, the realm of mind and soul, is in many ways a mirror to the outer space of stars and galaxies. In that exploration, we find perhaps the deepest connection of all. Inner space and outer space, two grand frontiers that at first seem entirely different, yet they reflect one another in uncanny ways. Look up at the night sky. You see countless stars scattered across the vast darkness around you. Now close your eyes and look within. You find thoughts and memories twinkling in the darkness of your mind. There is a structure to the cosmos at every scale. Galaxies form filaments and clusters arranged almost like a cosmic web, with great voids between. Curiously, if you look at neural networks in a brain, the pattern can appear strikingly similar. Neurons connecting in complex webs, transmitting signals across emptiness. One could almost imagine that a brain cell and a galaxy, different by trillions upon trillions of times in size, rhyme with each other in form. It might be coincidence, or it might hint at a deep principle of nature repeating patterns, as if the universe likes to reuse a beautiful design in varied contexts. Think of the numbers. There are on the order of 100 billion stars in our galaxy, and coincidentally, about 100 billion neurons in a human brain. Is it just chance, or does it speak to the vast and endless potential for complexity, both out in space and inside our skulls? Perhaps it is merely poetic parallel, but it fuels the imagination to think consciousness and cosmos might be parallel processes. Each of us carries within our head a structure as intricate in its own way as a galaxy. When you ponder the stars, there is a galaxy of neurons in your mind firing patterns that correspond to that thought. It's as if one vast system is reflecting on another. Our ancestors had an intuition about this mirroring. As above, so below, they would say, suggesting that the patterns of heaven are echoed on earth. In modern understanding, we see echoes of that sentiment in fractals and repeating natural designs. Spirals swirl in galaxies millions of light years wide, and similar spirals shape the shells of snails, the pattern of a hurricane on Earth, and even the twisting double helix of DNA. Spheres are the shape of planets and also of cells and seeds. The pull of gravity makes planets round. The pull of surface tension makes a rain droplet round. Coincidence or cosmic rhyme? Such patterns remind us that we are not separate from the universe, but part of its continuous creativity. Consider your very body. It is composed of the same elements found across the cosmos. We often recall that we are made of star stuff, but think of it in detail. The iron in your blood was forged in the explosion of a supernova long before the Earth existed. The calcium in your bones was brewed in the belly of a star. The oxygen that fills your lungs each moment was produced by generations of plants under the sun's light. But the atoms of that oxygen were formed in ancient stars as well. In essence, your inner space, the matter that makes you alive, is literally the ashes of long-dead stars, given new form and life. When you contemplate that, the boundary between you and the cosmos becomes blurry. You are a walking universe in miniature, with pieces of galaxies and stars inside you, dancing to the rhythm of life. Even the processes within us echo cosmic events. The electrical impulses in our nerves and brain are akin to lightning, or the solar flares of the sun, scaled down to microscopic intensity. The heat in our bodies is a tiny echo of the nuclear fusion in stars, as we burn calories in a controlled biochemical fire to stay warm and alive. The water circulating in our veins and cells once cycled through ancient oceans, clouds, and perhaps comets that delivered water to the early earth. The salt in our tears and blood is from the primordial sea that nurtured the first life, an echo of the ocean that once enveloped all living things, and the sea's tides answer to the gravitational pull of the moon, linking our internal chemistry to the movements of celestial bodies. Our lives are tuned to cosmic rhythms, day and night, governed by Earth's rotation, deeply affect our biology. In the daylight, stimulated by the sun, we are alert. At night, under darkness and starlight, our bodies release hormones that invite sleep. We carry an internal clock, a circadian rhythm that is essentially the echo of Earth turning under the sky. The moon's cycles have been observed to sway the behavior of various animals, maybe even our own moods. A subtle, monthly rhythm that mirrors the moon's journey around us. Across seasons, as Earth orbits the sun, we experience changes in weather and length of days, which shape our inner emotional landscape and energy. Many people feel uplifted as spring returns and the world warms, or reflective in autumn as days shorten. These are inner experiences directly tied to cosmic motions. Contemplate also the depths of time. The universe measures time in billions of years, the spans of star lifetimes and galactic dances. Our human lives, by contrast, span mere decades, a fleeting tick in cosmic terms. But time is relative to the beholder. For a butterfly that lives only a summer, that season is a complete lifetime, filled with sunshine and purpose. For an ancient star burning for 10 billion years, a million years, might feel like a moment of its existence. We, somewhere in between, perceive years and centuries as significant stretches. Yet in those brief years, we experience love, learning, and wonder enough to fill a universe. In this way, the ephemeral and the eternal coexist. Every short life is a microcosm of meaning against the backdrop of cosmic eons. Knowing how short our time is can make each day more precious, and knowing how long the cosmos endures can give us comfort that life and memory persist in some form. Even after we are gone, our atoms will rejoin the earth and sky, and time will continue weaving new tapestries. We thus partake in eternity, each of us a brief but beautiful theme in the endless cosmic symphony of time. Our lives are also part of cosmic cycles in another sense. Many cultures talk of a circle of life, and indeed we see cycles everywhere. Day giving way to night, winter to spring, the phases of the moon, the rise and fall of civilizations. These cosmic rhythms and cycles of days, moons, seasons, and ages remind us continually that we are part of something much larger than ourselves. The cosmos also influences how we see ourselves in a more philosophical sense. We project human concepts onto the stars: love, war, heroism, fate, and the stars in turn influence our concepts by their very existence, challenging and expanding our understanding. We saw how mythmakers did this explicitly. Now scientists do it in a different way. We contemplate the eventual fate of the universe. Will it collapse or drift forever? And it informs our philosophies about permanence and change. We learn that even stars are born and die, and it comforts us that death is part of a natural cycle, even on the grandest scales. We realize Earth is not the center of the universe, and it humbles us, influencing religious and existential thought. It's a dialogue. We ask questions, the cosmos answers with discoveries, and those answers pose new questions in our minds. On a very personal level, many people use metaphors of outer space to describe inner feelings. We say, "I need space," when overwhelmed, as if a mental equivalent of a starry expanse is needed to feel free. We feel starry-eyed in love, as if filled with bright lights within. Deep sadness can feel like a black hole that nothing escapes. A burst of inspiration might feel like a supernova in the mind. These are poetic, but they show how entwined the imagery of cosmos is with our vocabulary of emotion. It's as if our psyche borrowed the universe's language to articulate its own mysteries. These reflective connections between inner and outer extend even into how we search for meaning. We contemplate and personify the cosmos, and in turn, those cosmic realities challenge our perceptions of meaning. We saw how myths personified planets as gods. Now, the discovery of how small Earth is in the cosmic scale forces us to find meaning, not in being the center, but in being part of a vast community of worlds. The interplay goes on. We ask, we learn, we adapt our inner world view. Meditation is a practice that often explicitly unites inner and outer. Many meditation traditions encourage envisioning oneself as expansive as the sky, or to observe thoughts as clouds passing in the vast space of the mind. This analogy works because we innately sense that inside us is not just a cramped interior, but an open field of awareness. When you sit quietly and let go of the constant chatter, you may begin to feel your consciousness widen and become more still, like the night sky. Thoughts come and go like shooting stars or drifting clouds. In deep meditation, practitioners sometimes report a loss of the boundary between themselves and everything else, a direct encounter with that unity we have been contemplating. They might feel, even if briefly, that they become one with the universe, or that the universe is meditating through them. Even in a simple relaxation, you can gently taste a hint of this unity. For a moment, focus on the feeling of your body against the surface you rest on. Feel the pull of gravity, which roots you to the earth. It is the same force tethering the moon in its orbit and guiding planets around the sun. Take a slow breath, and as you exhale, Imagine any tension in your feet dissolving into the ground. Your toes and soles soften, and your ankles loosen. With the next exhale, feel your calves and knees release any tightness, your legs becoming comfortably heavy and warm. Breathe again, and let go of any holding in your hips and lower back. The earth is cushioning you. You can surrender your weight to it. Let your belly relax and your chest remain open as you breathe. Feel the steady rhythm of your heartbeat, steady and calm, like the gentle ticking of a cosmic clock within you. Allow your shoulders to drop, freeing themselves of the day's burdens. Your arms and hands rest easily at your sides, tingling with relief. As you breathe out once more, feel your neck and jaw unclench and relax. Your face softens and your eyelids grow heavy. From head to toe, a wave of ease flows through you, as if a stream of starlight were washing gently over your body, coaxing every muscle into rest. In a more everyday sense, simply closing your eyes now and taking a slow, deep breath can be revealing. With eyes closed, the visual outer world is gone, but you are not gone. You find yourself in a space of darkness with perhaps soft glows of colour from your optic nerves, a faint, ever-present inner light. Your sense of touch still tells you where your body is, but your mind can also float somewhat free of those confines. In that darkness, behind closed eyelids, you might imagine the night sky. You can place a star in your mind's eye, and it will appear. You can conjure the earth floating in space and see it with inner vision. This simple ability suggests that inner space can hold the outer space as an image, like a mirror reflecting it. The canvas of the mind is vast and capable of holding the whole cosmos in reflection. Now consider dreams again here. In a dream, your inner space creates an outer world for you to experience. It might be as boundless as the cosmos or as intimate as a small room, but while it lasts, it feels real. The material of that world is your own mind, yet you walk through it as if it were external. What is this, if not a hint that inner and outer are made of the same stuff in different arrangements? The waking world has consistency we share collectively, while the dream world is personal and ephemeral, but both appear to consciousness and can shape consciousness. Some philosophies, especially in Eastern thought, suggest that the waking reality too is a kind of shared dream, or that consciousness is the fundamental substance of which matter is a manifestation. In those views, everything is essentially happening within one universal mind, and our individual minds are like eddies in that great stream. Modern science doesn't endorse a specific metaphysical stance like that, but it's a poetic contemplation that resonates with the sense of unity we've been exploring. Even if one doesn't subscribe to such ideas, there's no denying the interplay. The material universe created the conditions for consciousness through life and evolution, and now consciousness in us examines and contemplates the material universe. It's a loop, like a serpent biting its tail, reminiscent of that dream image which revealed a truth. The universe and consciousness are entwined in a dance, each giving rise to new forms and understandings in the other. With this perspective, one might ask, is it the universe that dreams through us, or we who dream of the universe? Perhaps both. When you imagine distant galaxies or aliens or futures, the universe is imagining itself through you. When a star somewhere goes supernova and its light eventually stirs awe in an astronomer's heart, the universe is experiencing its own grand event through the intermediary of that awareness. It's a poetic way to see things, but comforting in its symmetry. Our joys, fears, and aspirations might be seen as the cosmos, having those feelings in microcosm. As our journey through narrative comes to a close, it is worth sitting for a moment with the immensity of what we've touched. We explored the far reaches of galaxies and the deep recesses of atoms. We sailed with ancient navigators and listened to the sky's stories. We contemplated logic and myth, drifted through dreams, and finally looked within ourselves as though peering into a cosmic mirror. Through it all, a single thread winds: connection. Everything is connected, perhaps not visibly or tangibly, but through resonance, pattern, and shared origin. It leads us to a gentle truth. The sense of separation is to some extent an illusion, and to be alive is to be a part of something vast, eternal, and yet intimately here in each moment. We have journeyed far in this exploration, sailing from the birth of stars to the depths of subatomic particles, from ancient myths to future dreams, from the outermost galaxies to the inner landscape of the soul. Through it all, a pattern emerges. Everything is interwoven. The atoms in our bodies link us to long-dead stars. Our stories and science together illuminate the same cosmos. Our dreams at night echo the creative forces of the universe. Even our solitary mind is a microcosm reflecting the whole. It is as if the universe has been holding up a mirror, and in it we see not only the cosmos, but also ourselves. And perhaps that mirror works both ways. When we peer into ourselves, we catch a glimpse of the cosmos. In recognizing this unity, we find a kind of comfort, a sense that we belong here, that we are a natural part of the grand design, as fundamental as a moon orbiting a planet, or a thought orbiting the mind. Now, gently bring your attention to your body, allowing the tranquility of your mind to wash over every part of you. Notice how you are supported by your bed or the ground beneath you, by the earth itself. The planet's gravity is like a caring hand holding you safely in place. Take a slow breath, and as you exhale, imagine any tension in your feet dissolving into the ground. Your toes and soles soften, and your ankles loosen. With the next exhale, feel your calves and knees release any tightness, your legs becoming comfortably heavy and warm. Breathe again, and let go of any holding in your hips and lower back. The earth is cushioning you. You can surrender your weight to it. Let your belly relax and your chest remain open as you breathe. Feel the steady rhythm of your heartbeat, steady and calm, like the gentle ticking of a cosmic clock within you. Allow your shoulders to drop, freeing themselves of the day's burdens. Your arms and hands rest easily at your sides, tingling with relief. As you breathe out once more, feel your neck and jaw unclench and relax. Your face softens and your eyelids grow heavy. From head to toe, a wave of ease flows through you, as if a stream of starlight were washing gently over your body, coaxing every muscle into rest. Finally, as you prepare to slip into the gentle refuge of sleep, release any remaining worries or thoughts. There is nothing you need to do now, and nowhere you need to be, except here in this peaceful moment. You are cradled by the cosmos itself, as you have always been. From the moment you were born, every atom in you has been kept in the delicate balance of forces that govern the cosmos. Gravity holds you to Earth and keeps the Earth circling the sun. Electromagnetic forces keep your atoms together and also generate the light by which we see the stars. Nuclear forces lit the stars that made the elements that became you. The universe has collaborated for billions of years to bring you here now. In a very real sense, you are the universe, in one of its many creative and conscious forms, saying hello to itself, feeling wonder at itself. So, rest now in this knowledge. The cosmos stretches far beyond, full of mysteries and marvels, and it also curls up inside your very being. The journey of discovery is endless, but there's no rush. We have eternity, in a sense, each of us playing our part for a time. As our spoken journey ends, the real journey goes on in every moment, awake or asleep. We close our eyes now on the outward scene, but the inner universe will light up with its stars in dreams. May your dreams be gentle and filled with the quiet grandeur of the cosmos. And when you wake, may you carry a bit of this starlit peace into your day, remembering that beyond the hustle of life, the cosmos and your soul move together in an ancient and endless dance. Good night and sweet dreams under the eternal sky above.